Welcome to the maker's world, where every spark of an idea becomes something real. Right here in Czechia, we build tools that peer into particles and launch satellites into orbit. It's where the word robot was born. And Čapek's vision of automation still fuels the imagination of today's inventors. From prototypes shaped at Fab Labs to bold experiments led by students, entrepreneurs, and researchers. This is curiosity in motion. The next era begins with you, innovating, exploring, going further. From clean energy to quantum breakthroughs, we're shaping what comes next. Over the next 8 days, Fabex comes to life. 42 speakers, 255 sessions, 100 chances to get hands-on, 5 evenings of conversations that matter, and 6 mobile Fab Labs, arriving ready to build, share, and inspire. From every corner of the world, you're coming to be part of it. This isn't just an event. It's a celebration of making, sharing, and shaping what comes next.
Good morning, ladies and gentlemen. Hi. And welcome to day 3 of FAB25 Czechia. I hope you enjoyed yesterday's program and congratulations for conquering the castle. In fact, it was our second after party in a row, so I'm just curious, how is your energy level? So shall we do energy check? This means totally hungover, want to go to bed, can't believe I'm even here. And this is totally hype, excited, let's get it started, I'm ready to go. So where are you on this spectrum? Okay, cool. Alrighty. Party animals are sleeping still, so maybe. So yeah, we are good to go. Here's how the day will flow. Today we'll have the FAB conference and the afternoon workshops, and in the evening you will have time to explore the city by yourself and then maybe stop by Harry's. It's a local brewery we booked for you. But before we jump in, just a quick practical note. You already know the drill. The layout of the day is the same as yesterday, so moving to our second location, we'll be going to university for afternoon workshops. Please do not bring any food or drink. It's our one and only rule not to have food or drink in the auditorium, so you can enjoy your coffee, snacks and drinks in the theater foyer. And now the fun stuff, social engagement. It's been so great to see how you are enjoying FAB25. So thank you for sharing it through the social media. We are watching your photos, videos, we are watching it all. And yes, we saw a Peruvian delegation in a local pub. We saw you making a bunch of stuff during afternoon workshops. We saw you exploring art in a city center. And we saw people from all around the world dancing to classical Moravian folk cymbalum music and even more to Malalata. And yes, we saw the tattoos of Neil. So please, keep them coming and feel free to use the hashtag #BridgeTheGap and to tag our social media profiles. And thanks to our general partner, Prussia Research, for supporting FAB25. Today, we are shifting focus from how we make things to what's coming next. Over the last 20 years, Fab Labs have become a truly global network, and as we heard yesterday, they're all a little different, and that's a good thing. Every lab is shaped by its local context, its people, culture, community. Some are based in schools and universities. Others serve rural areas or big cities. Many have become a key part of innovation ecosystems. But no matter where they are, Fab Labs are full of ideas and full of potential. They spark creativity, they teach hands-on skills, they build confidence and empower people to solve real problems. They're where things get prototyped, tested, hacked, and reimagined. And more, they're also where products are born. Today's track is all about the next step, going from maker to market. You will hear stories of people who made the leap from Fab Lab ideas to successful products. We'll hear how Fab Labs empower not only entrepreneurs, but also teams, employees, and communities. We'll dive into open source product development and explore the pros and cons of going open. And we share practical tips for a successful product journey. Because maker to market, we believe, is not just about launching businesses. It's about strengthening careers, supporting talent, and building sustainable entrepreneurship, all while staying true to the core values of the maker movement. And same as yesterday, we offer you one simple question to think about during the day. And today's question is, how can Fab Lab support not just great ideas, but the people behind them at every stage of their journey? Yeah, you can take a photo of this question, and remember, there is no right or wrong answer. It's just something to carry with you, reflect on, or discuss with some of your friends and colleagues over a coffee. Now, the morning just wouldn't be the same without some fresh and fabulous announcements. So today from Neil again, but before him, it's Rodney Williams, Program Manager for Education and Outreach at FAB Foundation. Please welcome him on stage. Hello, Rodney.
Thank you. Good morning, FAB25. So I believe I can get used to this. They mic'd me up and powdered my nose, so I might not want to get off the stage today. So yes, I'm Rodney Williams. I'm the Program Manager for Education and Outreach with the Fab Foundation. In this role, I get to work with K through 12 schools, higher ed institutions, and then our corporate partners. So today I'm here to spotlight one of our corporate partners, that is Chevron. As you know, Chevron is a petrol and chemical company, but over the last 12 years, they've made a commitment to STEM education and workforce development. Today I want to highlight Karen Rawls, who is the Social Investment Manager for Chevron. Karen, 12 years ago, met with Sherry and decided to put Fab Labs into cities in the world, in the US and in the world. So 12 years ago, now we have 20 Fab Labs and mobile Fab Labs through Chevron. So they made a definite commitment, and we're thankful for that. So thank you to Karen Rawls for making that commitment. So as I mentioned, 12 years ago, we had a partnership with Chevron to get these Fab Labs and mobile labs together. And we've had hundreds of thousands of direct users since that time, and they've done a wonderful job. So we've had 20 new labs in the network. I know we have one Chevron lab here from Fort Valley State University this year. So if you guys see Heaven, make sure you talk to Heaven. Within that, we have labs at the bottom here. You can see some of the labs are primarily at universities and K through 12 schools. Some labs are at community spaces as well. But the work has been intentional and the impact has been great. So we're so excited to continue this partnership. Within that, one of the newer labs is called the Central Coast Mobile Fab Lab. It's a combination of Hartnell College, Monterey County Office of Education, and California State University, Monterey Bay, and they have come together to form the Central Coast Mobile Fab Lab. And this is some of the work. I don't know if you guys were in Mexico last year, but they bought Luna. Luna is an animatronics figure that is created for storytelling. So Norella was actually the voice of Luna at our conference last year. Also, another aspect that we have is the Scopes DF platform. This is something that Chevron has also supported as well. If you aren't familiar with Scopes, please go to the website scopesdf.org. This is a platform where you can post lessons and find lessons based on digital fabrication. There are also contests for educators. We need more educators to submit activities and lessons for those contests. You actually get to win some money, so please do that. This year we had our third iteration of the Fab STEM Fellowship. We want to highlight our 2025 fellows, Dow, Grisella, and Gracilia. They are the 3 fellows this year. Within the fellowship, please apply next year. You can win $10,000 stipend and go to two labs, one in the U.S. and one international lab. Within that, the fellows get to do a podcast and a lesson with the lab that they go to. So this is a great opportunity. We're really excited about this. If you see, the fellows may be here. If you see them, please speak and say hello. So with that, Chevron has also made an international impact, so we're thankful for that, especially with the fellowship. We've traveled to Japan last year, Switzerland, and we're also in the U.S. in those labs as well. So this map shows the places that we've been this year with Chevron. If you have any questions about the fellowship or anything else that has to do with education, please reach out to me. You can use this QR code. I'm happy to meet with you guys. You guys' insight is important in perspective, so I look forward to hearing about that. So thank you.
Thank you, Rodney. And another announcement is coming right up, so please welcome Neil Gershenfeld on stage.
And if I could have the slides I'm going to show up. Good. Good morning. Congratulations again for waking up. How late did the party go last night? So, day one, my challenge to you was scaling our impact. Day two, my challenge was transition for Sherry and me. Day three, I want to unpack what's happening with education programs. And this really represents a kind of profound change in what is a Fab Lab. What does a Fab Lab mean? And so I'm going to talk through 4 or so programs. So the first one is this one. You're probably familiar with Fab Academy. It spun off from the MIT class. It was really the basis of why we created Fab Labs. It's had this profound role in the network, maybe the most important binding in the network, in that it propagates best practices, it trains trainers, builds a collaborating global cohort, it really drives the technology roadmap. However, I've been teaching it for 20 years, and that's enough. But I'm not retiring, I'm not leaving it, I'm changing my role. So right now, I do everything for the class. I plan it, I develop the examples, I teach it, I record it, I review the students. Instead, I'm going to be moving to curating it. And we're putting together 2 new groups. So one group is the global faculty. And so in addition to me, these are all world leaders in their field. So Adrian Boyer is the pioneer behind RepRap, which is largely behind much modern FDM printing, for example. Massimo Banzi, you met last week for Arduino. Tony Schmitz is the US national leader in machining, in machine tools, how tools and materials interact. And so we have this group of global faculty who are world leaders in the subjects of Fab Academy. And then really exciting for me is this global instructor group. And this is a first pass at it. There's about 20 of them. The global instructors have been instructors in Fab Academy for many years, and they've each emerged as leaders in areas of the Fab Academy. And together, the global faculty represent emerging best practices in these areas, but some, but not all of them, are familiar with how Fab Labs work. The global instructors are deeply enmeshed in how Fab Labs work, and together these teams are going to be driving the Fab Academy. So I'll curate the teams, I'll frame the class, I'll do quality control, but each week is going to be a collaboration of both global leaders and these global instructors covering the material in the class, and then I'll pull together at the end. And so Fab Academy 2.0 will be everything you know and love about it, but it's going to scale beyond just me to these 2 global teams. And so we're going to make that transition for 2026. So that's what's coming for Fab Academy. Then this is a really exciting program. Last year we all gathered in Bhutan. No, 2 years ago we gathered in Bhutan. Last year we gathered in Mexico. And Bhutan has fabulous natural resources, incredible human capital, a lot of national needs, and a lot of the young people are leaving the country for opportunity. And meanwhile, vocational training there was training 19th century, many of it is 19th century skills. And so Bhutan asked if we could help with their vocational education. I gave them a shopping list of new topics, and they said yes. Rather than picking one, they wanted all of them. And so it led to the idea of creating this interesting new format, which is a bit like the landing pattern of airplanes at O'Hare. We're going to teach 21st century vocational skills, not 19th century. And rather than picking one, we're going to have 1 month sprints, where in a month you learn what the skill is, you learn the tools, you do a basic example, and then a small project. In a never-ending series of sprint introductions. And so the first ones we've queued up, and again, this is driven by national leaders. So cybersecurity, Radia, although she hates the term, is the mother of the internet. She's behind internet routing. With our partner Charlie, she wrote the book on cybersecurity. Ben wrote a large part of Apache. He's one of Google's leading security architects. Francois is probably one of the world's leaders in hardware security. So for example, that's the group for cybersecurity. We're going to do one on microelectronics, design for manufacturing, scaling, robotics. And the idea is we'll have this never-ending series of sprint introduction to 21st century vocational skills, real hands-on applied skills. And from there, you can cycle through all of them, and then these can in turn spawn off deeper programs to grow. And so we're going to be rolling this out as a trial this fall. Jean-Michel Molinar is working with me to coordinate this. I don't have the URL here, or it is here. It's futures.academy.org, but if you're interested, reach out to Jean-Michel. And one of the hopes for this is going to be much more scalable to propagate our education. A third one is incubation, and you're going to hear a lot about this today. The educational programs are working. We've been failing the step after that. There's a real mismatch with traditional incubators that want to know their exit. They're very variable. They're very local. They can be predatory in taking advantage of entrepreneurs. And so I've put together a team of amazing, successful entrepreneurs, like Diane Green founded VMware, the basis of virtualization in data centers, and she built Google's cloud, and she was chair of MIT's corporation. A series of these really remarkable people who have had a tremendous impact and are thinking about their legacy. And rather than you going to the incubator, we're going to turn the whole Fab Lab network into an incubator where you stay grounded locally in your community with your local resources, but then we bring in this global mentoring in best practices in incubation to use the whole lab network itself as a giant global incubator. And then finally, Academy, the name was a joke, the Academy of Almost Anything, but it's becoming very serious. So these are a bunch of steps we're doing to formalize Academy as we take on more and more programs through it, teaching empowering knowledge guided by global leaders in a network of connected local labs. And so there'll be more coming about that. But the really interesting thing I'll leave you with is I haven't said laser cutter once. Fab Lab started from getting access to the laser cutter. What they've really done is built a community and a culture around peer-to-peer project-based learning, invention, just-in-time, think globally, fabricate locally, collaborate, all the values we hold dear. And the network is really pivoting into, there'll still be laser cutters, but it's really becoming a platform for global learning. And we towed the learning behind the tools, but now sort of the tail is wagging the dog. And in many ways, the global educational platform is really the heart of what we're doing, and it does include a laser cutter. And so this is a really interesting moment in the transition of our journey for the future of the educational programs in the lab network. And so if you're interested, reach out to me. Jean-Michel is helping with many of these. This is all linked through Academy. Luciana is a point in organizing to help with follow-up. Thank you.
Thank you, Neil. Coming up next, we are diving into the maker-to-market journey. When you start building and prototyping something in a Fab Lab, one of the first things you'll need is a solid 3D model to make sure everything fits and to make changes fast. And when it comes to 3D modeling, one of the most popular tools out there is Solidworks. Up next, we'll hear how this powerful software can help turn your maker idea into a market-ready product. So please welcome a longtime partner of the FAB Foundation and FAB25 from Dassault Systèmes and Solidworks. It's Suchit, Jain.
Thank you.
Welcome.
Okay. Good morning. How's everybody doing? Well, so my name is Suchit Jain. I'm with Dassault Systèmes Solidworks, and coming to this event every year is my favorite time. I travel all the time, but coming, and I know a lot of you guys, so what I wanted to do was tell you a little bit about Dassault Systèmes and Solidworks. A lot of you people who've been working with us probably know about it. But Dassault Systèmes is one of the largest CAD software sort of product development company. We empower students and companies across. We always are very proud to say that 60 to 70% of everything physically you see, whether it's your shoes or the plane you fly on the chairs you're sitting, everything, our software has touched and enabled the innovations coming across. We have around 25,000 people within our company working across the globe, a lot of them engineers, and we are really very proud of being part of the STEM revolution, if you will, right? We're empowering STEM and enabling especially what you guys do all across. Solidworks is one of the brands within Dassault Systèmes, and a lot of you probably, when you've back in your school days or even in the industry or even today at the maker spaces or maker labs, in Fab Labs, you must be using Solidworks in a lot of cases. We have over 8 million people using Solidworks, nearly 5 million of them students in early education. And from the early days of SolidWorks, we are celebrating this year the 30th anniversary of SolidWorks being introduced way back in 1995. And we were very early on, we were very focused on providing the software in the STEM education. So we are very proud that out of these 8 million, nearly 5 million are students using SolidWorks software. And the journey sort of continues from students using the software to professionals using it, and a lot of times startups doing that to create their innovations and bring their products to the market. And of course, it's in various industries. We talk about 12 industries. A lot of times, SolidWorks is very well known in the industrial equipment area, but robotics or high-tech, medical sciences, et cetera, quite a bit. And our portfolio is sort of based in hardcore science, if you will. So of course you have CAD, you have CAE, CAM, a lot of visualization stuff, and a lot of data management. So when you, for example, if you're building a plane like Boeing's planes or Airbus, et cetera, there's millions of parts, there are thousands of suppliers. Managing all that supply chain is also what we provide. We provide tools to be able to do that. And as I said, it is built on science, so you will see a lot of software tools to be able to go from, of course, Neil talks about from, nanoscales to macro scales. So we have ways by which you can do material science modulation, simulation, those kinds of things, and we attach into design, simulation types of things. We have invested quite a bit in material science as well, and also in pharmaceutical research, et cetera. So it's not just about, structural and CAD. We get into the molecular level software as well. And over the years, something we are very proud of, and some similarities we have with the Fab movement, if you will, is the community. We are very proud of the engineers and the community which has been using our software. As I mentioned, we are 8 million plus users. A lot of, if you go in social media and so on, you'll see a lot of activities happening. I mentioned STEM, over 33,000 institutes. So no matter which four-year university you will go across the world. Earlier, I was in Vienna this earlier week. We were at TU Graph. So you'll find SolidWorks in a lot of different places, and something which my friend Abhishek is here as well. You please catch him. He's in the audience right now, but he manages our startup program as well. So we work with a lot of startup companies, and I heard backstage earlier Neil talking about turning the Fab Lab into incubator, which we have talked quite a times about it, that a lot of innovation happens by you guys. How do you turn that into startups and so on? So I'm very glad to see what Neil announced. Something we have been working with a lot of incubators and accelerators, of course, providing the software, but also the network and the help needed to get that. So something we are very proud of it as well. And I'll skip this video for time's sake, but here are some examples of companies. So this was a startup in air mobility. I think the video is playing, yep. So they use magnetic levitation technology for propulsions for clean air mobility. And of course, you'll see that they are not only just doing the shape and the structural design, but a lot of using aerodynamics and fluid flow simulations, because key stuff with our software, and each one of you can benefit from it, of course, and I'm sure you're using it. If not, you should, because it allows you to kind of mix that virtuality, the ability to test things, because physical making costs money, right? You're cutting metal, you're shaping metal, et cetera. But if you can test a lot of things virtually fast and then produce it only a few times, then you save time and money, right? So this is what these companies are doing. This Metalworking is a servicing company. They provide all kinds of production services for CAM, metal or forming, sheet metal, stuff like that. And they have turned into sort of creating the virtual factory of the future, if you will. So a lot of things, when they get their designs, they're able to produce the parts in a much more cost-effective way. And they're using a lot of these robotic programming and automation tools to be able to do. And of course, at Dassault Systems, we provide software to really virtualize the factory floor as well. So whether it's a little shop or it's a huge factory floor, imagine cars and planes going and robots doing a lot of the work in there. It's just about the time and money. This is another example of a infrared, so LINRED, which is an infrared detector. So a lot of physics, again, going in there. So again, not just shape, but a lot of the thermal aspects going as well. A little bit, as I mentioned earlier, we've been working with Sherry, with Neil, and with you guys for since, I'd say, 2014 in a lot of ways. And it started with our journey with Fab Lab in Rwanda, so you'll see a lot of the pictures. I've been to Rwanda several times along with and I remember the first time in Sherry, I can see you sitting there. So I think you remember our trip over there. It was a lot of fun in both making and really changing our country. And today they're doing some amazing things around it. So here are some pictures of those things. There's a picture of the Shenzhen Fab event. Here are some more pictures with President Kagame. I see you probably from Rwanda. You'll see him in the background. Of course, our lunch in Watham, probably. I think, Sherry, you are there, and Neil is, of course, in there. Another thing on Fabry Academy. So we've been part of it. As well, and we have a Fab Lab in Watham on our campus. Watham is in Boston area, so North America. If any one of you is visiting, well, I'd love to host you. Abhishek actually is, as I said, is in the audience. He runs it, and we have hosted some of these, and we have sponsored some of the Fabry Academy graduates as well. So if you have an interest, please catch us, and we can see what we can do to help you. Also, Fab Academy, so you heard Neil talking about that earlier. We also have sponsored cohorts in there, and we have run classes. Neil's lecture sort of broadcast from the Waltham Fab Lab as well. Again, this is something if selectively we can sponsor and support some students as well. So this is a call for you. If you guys please come talk with us on that as well. And this is an example of Jose, who's in Chile, was a good student. He was a resident in our Waltham lab material, and now he's started his own company. So this is a real example of somebody going through the maker journey and starting a company. And that company is doing very well now in material packaging industry. And of course, we do a lot of professional, I'd say within our company, so that's up in the picture, you'll see a lot of people who have turned into doing hobbyist project into professionals. We have our own, the guy up there, you'll see Sal, who works, and Eric Beatty. These are all our customers of Solidworks, but also hobbyists and doing a lot of stuff personally, and they're turning a lot of the innovations and the work they have into useful things for the society. It'll be a great experiment for us. So we actually bought the two-seater plane. It comes in a kit, and then we assembled it, and some of it, so that's Bernard Charles, our chairman and CEO of Dassault Systems. He's working and helping us assemble the plane as an example. So my point of showing all of this is that the making is in the heart of our, sort of the DNA of our company. And this is also a lot, very small amount, like $50 per year or something like that. So we have a community of people making a lot of the things, and then they market and showcase their project. So I'm running out of time, but I'll close with a quick offer for you guys. So the first 200 people who sign up on the QR code, you'll get the maker license of SolidWorks for 1 year at no cost. So if you can grab, I think there are of course more than 200 people here. So if you have an interest, and anyways, come talk to us. We'll figure that out. So that's all. I wanted to give you a quick journey on.
And now it's time for today's keynote. And it's coming from someone who's gone all the way from maker to market. And just so you're ready, if you'd like to ask him any questions, just send it through the Eventi app, find this particular session, and hit Ask the Question button. Back to our keynote speaker. He's a Dutch designer, entrepreneur, and open design visionary, known for building bold, sustainable solutions from the ground up. He co-founded Fairphone, the world's first ethical smartphone company, and later he helped launch The Click, a circular food startup. Along the way, he also founded Fab Lab Amsterdam. He's a true maker at heart.
Thank you. Wow, I'm so excited to be here. It's really, hey, that's what I mean. It's a lot of people I haven't seen for a very long time. It feels like I've been under a stone doing Fairphone, but I have to tell you, this is going to be all about what I've learned in that time when I was doing Fab Lab. Hey, Marlene, wow. So got the idea of the Fab Lab around that time, and it just clicked. It really clicked with all the stuff we were doing. It was a match made in heaven, so we fell in love. And obviously, the next thing you do is set up a Fab Lab. And one of the things we did is we set up the Fab Lab in Amsterdam in a very old building, which you probably showed already. And I was lucky to be able to do that and to run it. And I also remember, and this is such a while back, that we actually organized the Fab6 conference, and that was in 2010. And I think we all fitted into one photo. I'm not. So I took my screwdrivers, I took the Nintendo, and started screwing and screwing and screwing. And at a certain point, then the metal dust came falling out of the screw holes. Well, there's enough people here that already know that when that happens, well, you screw up the screws, because that's a no way back. Because when you screw up the screws, you're screwed. And I can tell you, I was pretty upset with it, because I found out the hard way that Nintendo did not want me to open up that device. They used back, sat on the couch, and contemplated, why does Nintendo not want me to open up a device that I own? And I don't know if you guys remember this, and I don't know if Dale is in the audience as well, but this was important stuff to me at the time. My motto in life has become, if you can't open it, you don't own it. For a lot of people here, that was so important. At that time that we were building this maker movement, we wanted to be able to open up stuff, and then the stupid Nintendo makes you, block that, and we were on a fight, and we knew we were going to win that, because things would get better. Because we were on a roll with this whole maker movement, and the products will definitely get better and better over time if we show that it's important. Well, I can tell you, the life of a tinkerer hasn't become easier, especially when you look at this product. It's a bit of a shame, and people are laughing already. Is there anyone here who recently has replaced the battery of the phones? Probably a lot more here than in general. How was that experience? Awful, okay, yeah. So you didn't have a Fairphone, hopefully. It kind of proves already that things got out of control, and you might even say that we're suffering from smartphone anorexia, because things are getting thinner and thinner and thinner, and the thinner they get, it is becoming a real problem. The thinner they get, the more technology has to be put into all these devices. Apartments to actually change the battery. I'm not even talking about changing the screens and stuff like that, because you need an expert for that, or even a robot, or whatever they do in these shops. And the result of that is that we use our phones on an average of 2 to 3 years only. And that could be much, much longer. It's a huge shame. But you all know the situation. You've been using your phone for 2 years, the battery goes down. Batteries do go down after 2 years. It's just how batteries work. We haven't invented the battery that doesn't go down after 2 years yet. You have a crack in your screen, and then your carrier comes with a new subscription and a new phone. And you think, well, what the heck, I'll just take that new phone. And what you do with your old phone, you take the old phone, you toss it in the drawer with all the other phones. Anyone has a drawer with a lot of old phones? Yeah, so we all have that drawer. Result of that, if you don't use the components, is that only 15% of these phones are being recycled. And we have more phones than people on the planet nowadays. It's the biggest growing electronic waste stream of our times. It's the biggest waste problem that we have currently. Electronics. And the solution is actually very, very simple. It's easy to solve. Because the longer you use the phone, the longer you use your product, the better. Let's do a simple calculation. If you use your phone twice as long, you only need to produce half the amount of phones. You only have half the amount of electronic waste, and for the mathematicians amongst us, it only costs you about half the price. So it's kind of stupid that we don't keep our phones longer. So that's why we at Fairphone designed a phone that is fully made for you to keep holding on to your phone as long as possible. It's easy to replace the battery, it's easy to replace your screens, everything is accessible with screws. Our newest phone that we just launched is made out of 12 modules. It's a bit like Lego. You just, when something breaks, you order it online, you get it shipped, and you take your screwdriver and you change the part. But not only that, making it easier to keep your phone alive like that when something breaks, we also give 5 years of warranty, and we give 8 years of software supports and upgrades. That means that if you buy a phone now, we will keep you supported until 2033. And we all do that because we want you to hold on to that device as long as possible. And like I said, it's good for you, it saves you money, sure, but what's more important, it's very good for the environment. If you use your phone twice as long, that means that you reduce the footprint of that device by 30%, because most of the harm is already done when you have a phone in your hand. It's in the production, it's in the supply chain, it's in the water they use, it's the land depletion, all this stuff that's behind the scenes that we don't see. So it's the best thing to keep holding on to that product as long as possible. Why isn't the whole industry doing that? Well, it's a rhetorical question, of course, because nobody is doing that in the industry. We're trying to do it, but the industry is actually doing the opposite. It's like clockwork. They change every year, and all the components change. And people that are in electronics, they know how fast components change, and how end-of-life calls, and minimum order quantities, and this and that. And how can you change that? How can you make an impact in an industry that is so short-cycled and only focusing on selling more, producing more, because that's their business model? You can't just do that by creating a design that is focusing on having people keep that product longer. You also have to fight that fight on another level. And that's why I sent a letter to Frans Timmermans, who was one of the Euro commissioners at the time. And said, this is in 2011. And I sent him a letter, and they were setting up the Eco-Design Directive. If anybody knows it, the Eco-Design Directive is a directive in Europe that they set up for manufacturers of electronic goods that they force them to make them repairable. But they would or make them, design them in a repairable way, and support them with spare parts over a longer time. But they didn't want to include smartphones. So I said, please include smartphones also in the Eco-Design Directive. And to my surprise, I got a letter back and said, well, we'll take it into consideration. And then I never heard back from them again. It's the EU, right? Takes a long time, obviously, because I was very happy when last year news articles started popping up that smartphones now are also part of the Eco-Design Directive. Since last month, all smartphones being made need to be repairable, need to be supported longer on software, all because of this design directive. Batteries needs to be replaceable. And I'm not saying that's because of my letter. There was a whole lobby going on. iFixit was part of that. The whole right to repair. People were like doing all kinds of things to make sure that this bill would get passed. And we have been lobbying there as well as Fairphone. But it really set something in motion. And what really put a smile on my face was this. When I was like a year ago, 2 years ago at Mobile World Congress, Nokia launched a repairable phone. Well, of course, obviously, they have to. But they were going to take Fairphone head-on in competing with our repairability. And why this put a smile on my face is because this was the plan from the start. Our theory of change, how we want to make impact at Fairphone, is that we want to raise awareness, show what the problems are, look, these phones aren't repairable, show them that it's possible, see how easy it is to make a phone that you can actually replace your battery, and then motivate the industry to follow us. Like Nokia seeing the market into repairable phones as well, or maybe forcing by pushing legislation together with other parties. And this is how we scale all of our innovations. And I'll tell you a bit more about these innovations, but I'd like to go back to the start, to the Fab Lab, because campaigning is in the DNA of Fairphone. At that time, we were doing a lot of work on open design, open hardware, open source software, and I was running that lab, and I saw all these people working on all these projects, and I saw one thing that really caught my attention is that when people start working on these projects, the relationship with the objects and with the matter and with the products also changes. And you've seen that, you've all seen that when you're part of when you're part of that making process. It does something with you. And you also take more responsibility. But at the time, a friend of mine, he came to me and he said, listen, I'm setting up this campaign around conflict minerals. Minerals being mined in Congo, for example. Millions of people died in the mining of these minerals, and these minerals are being used in our phones. And would you, with WAG Future Lab, and you, would you be interested, because you're using technology, you're already being critical towards technology, would you be interested to set up that campaign together with me? Because you guys are the ones that can question the very core of technology, and that is the mines, the factories, all that dark matter, all that stuff that we hid behind the scenes. And I'm a designer, so I was intrigued right away because I've been working on technology, I've been doing prototyping, I've been sending files to China and got like a container of PCBs back. And I've always been wondering, like, what happens behind that scenes? And this gave us the chance to really dive into that supply chain. But where do you start? The bill of materials, the components of a phone, is over 1,000 components made by hundreds and hundreds of factories. There's more than 60, 70 minerals going into a phone, mined all over the world. And if you want to make a fair phone, or you want to improve that, or want to raise awareness, where do you start? You can't just say, come on guys, let's create world peace, you want to join? No, you need an entry point. And one of the things that, as a designer, has always fascinated me, is that when you look around you, everything around us and all technology around us basically just comes from the ground or grows on the ground. It just comes from somewhere. This phone you hold in your hand, this technology you have, we are able to produce something as complex as a smartphone from starting somewhere in a mine, digging up stones, working together in an economic system. Not one individual in this room or in the world would be able to fully understand the complexity of the products that we produce through our economic system in a collaborative way. And that's fascinating. It's kind of a magical thing. But we also know we got alienated from who makes it? Where does it come from? Where does it end up if we don't use it anymore? All these questions, we don't ask it anymore because we're part of this economic system that magically creates all this stuff. And that's when I thought, like, wait, if that's already happening, why don't we just make a phone, make that as a starting point, a platform like Fab Lab, right? A platform where we can together find out through the eyes of a phone, step by step, what that world looks like. It's like a research project. But we do it as a company because we have to run into all the same problems. And then through making that phone, step by step, we can take people along, we can do all kinds of design challenges, we can pose questions on what can be done better, and we involve the industry, and then we come up with solutions. And these solutions, we'll try to scale them so that the whole industry can use them. And we call it Fairphone. So that's what we did. I made a card, Bas van Abel, CEO, Fairphone. There was another bunch of people that made cards of like some fake positions. And we took the plane to Congo, and that's where our journey started. And I'd like to walk you through what we found when we started this journey of Fairphone. This is a stone I'm holding. Is anyone familiar with cobalt here? Probably a lot of people. Yeah, you know what it's used for mainly? Milling bits. Huh? Milling bits. Yeah, I think that's tungsten. I think tungsten is used, but cobalt maybe as well. But cobalt now is really like it's one of the hottest minerals. That's one of the most important minerals geopolitically. It's being used for batteries, a lot for batteries, and it basically is needed to fuel our energy transition. We need a lot of it because we need renewable energy. We need batteries for that. We need infrastructure for that. So there's a lot of pressure on areas like Congo, where I found this stone, to get that mined. They say about 60% of the world's supply is in the ground in Congo in areas like that. And I got this stone from this guy, this mine. He dug like 30, 40 meters deep under the ground to make possible that we can drive our Teslas and that we have our batteries in our phones. Unprotected. 250,000 people are still working unprotected in these kinds of mines to mine cobalt. And it's not the only problem. Tens and tens of thousands of children are also in those mines working so that we can have our devices. And on top of that, a lot of conflict is connected to these mining. The areas are very prone to conflict, and millions and millions of people have died in conflicts related to the mining of these minerals in this Great Lake region in Africa. And then we have these minerals, and we make components out of it. They go to factories where people work 12 hours a day, 7 days a week, for a minimum wage. Great, but doesn't mean that you can live from a minimum wage. So you make more overtime, and you're in this loop of ridiculous hard work to be able to make these devices that we love so much. And a couple of months ago, a year ago, I went to Ghana to see also, and from my own eyes, how much of a problem the electronic waste problem actually is. A lot of our stuff that we don't use anymore, if we recycle it, if we reuse it, which is great, ends up on dumps in Africa or in Ghana. This is Abagloshi, one of the biggest electronic waste dumps in the world. And they burn the stuff because it's very difficult to dismantle it. Can you imagine if everything is glued together and you can't even take out modules, you can't separate the battery from the rest? Well, they just burn the whole thing. All the chemicals go into the soil, and well, I don't have to tell you how problematic that is. And then you go to the Mobile World Congress, to the technology conferences, and you see you see it's great, right? You see all these bling bling colors. You have foldable displays, you have bendable displays, you have phones with 8 cameras, but what you don't see is the color green. And then you think by yourself, I don't want to depress you all too much. You think by yourself, how the hell am I going to make impact in such a big industry with so many problems? And a quote I'd like to share with you that helps me when I have this feeling that things are too big. It's from the Dalai Lama. If you think you're too small to have an impact, try going to bed with a mosquito in the room. And we wanted to be that mosquito. Fairphone wanted to be that mosquito. So what I did is I had that bag of stones, I had these minerals, I had this cobalt stone, it was the only thing we had, but that was going to be a Fairphone. So I think together with Klaas, you still there? Yeah, Klaas. We went. I went to several companies with the stone, tried to convince them that this was going to be the next big thing. They all just kicked me out. Obviously, that was first thing they did. Like, this not our business. But we ended up at KPN, and at KPN we sat at the table, put the stone on the table, said, guys, listen, this is going to be a Fairphone. And if you're going to buy thousands of these phones now, you are going to be our launching partner. And then everybody went silent, and I thought, okay, they're going to kick us out again. But then one guy stood up and he said, I've read a book about Congo on my holiday, and we really need to do something about it. We really need to make this work. So a couple of weeks later, we had a contract with KPN, and KPN is the biggest operator in the carrier in Holland. We had a contract with KPN that they bought 1,000 of our non-existing Fairphones for a maximum price of 450 euros, and they bought it from a company that didn't exist, that never made a phone before. But we had a contract of 1,000 phones, so we were in business, right? So what we did, we quickly set up that company. We had this in our pocket. And what do you do when you're going to sell products that you don't have? Well, you set up a crowdfunding. So we set up a crowdfunding video, and that got really around virally. So I'll show you the video that we put online at that time.
Stuff. More stuff. All this stuff. You name it, we have it. But what we don't have, a clue about what's inside this stuff. We don't know where it comes from, or who made it. We know almost nothing about our stuff. That's why we started with an alternative for the thing we can't live without. Our phone. We are the people of Fairphone.
Hey.
Hello. Good day.
Hoi.
Guten Tag. Hello.
And this is what we're building. The Fairphone. As smart as other phones, but fair. Which makes it more than a phone. It's a beginning, a step in the right direction. We're making it happen. A smartphone that's made in a way that puts people and the environment first. We're already working hard on the first batch. We're almost there. And that's where you come in. To start making them, we need you to pre-order. Because by buying and owning this phone, you can make a difference. You become part of change. Buy a phone. Start a movement at fairphone.com.
So we got the business up. What we did is we had a website, one of these online shops where you can just start selling stuff. So we put a button on that shop, buy this phone for 325 euros, and we'll ship it probably in 6 months. And what happened is within 2-3 months, we've sold all the phones that we were going to produce. We sold 25,000 phones that didn't exist. And again, by people that never made a phone before, so there was a lot of trust by people. And we had 7.5 million euros on the bank account, and we were in business, as I said. And I slept like a baby. I woke up every 2 hours and cried. Because I had no idea what we were doing. I had my partner at the time, she was looking at me, I was crying in bed, literally crying in bed, and she, we just had all this, like, people, we got 7.5 million euro on the bank account, and we were about to send, like, 2 million to the Chinese factories to start building those phones. And I had never, the biggest team I ran was 2 interns. Well, Jean-Michel was my intern at the time, I think. Where are you? Yeah, so that was my team, right? I never ran a company with a lot of people. I never went into business. I'm a designer, I'm a creative, I did art school. So I had all these arguments, and I told her, you know what? We made a point. I'm just going to send back everybody their money and let somebody else do it who actually knows how to do this. But, the campaign is very successful, so yes. And then she just looked at me. I said, Bas, seriously? You pussy. How the hell? You are never going to get a chance like this in your life again. And the people that bought that phone, they didn't really buy a phone, for Christ's sake. They bought into an idea. If it fails, it fails. And you can't fail anymore. That campaign is already beyond what it would ever mean. And I'm very happy she did that, and I got the support, and went into this journey. So overnight, I transferred the money to China, did this, and we were producing phones. And 1.5 years later, we had 40 people working at Fairphone. We sold over 60,000 phones. We had a 16 million euro turnover, and we were the fastest growing technology startup in Europe. So that went really fast, and as a company, you can imagine that does something. But what was really, really more important is that this little mosquito that we were was already the best in class when it came to sustainability. When you compared us to the big companies, there was a Greenpeace report in 2016 that did a research on the greenest consumer electronics companies in the world, and Fairphone scored highest, and we were probably the smallest consumer electronics company in the world. So you can imagine with us having maybe 2 people working on impact, Apple, who sure, they score high, not as high as Fairphone, but yeah, they did well, but they had whole departments. It's like the biggest company in the world. It was beaten by this little mosquito that just didn't even know what they were doing at first, and was doing things differently. So it was really possible. I have to say it was also very, very difficult. So at a certain point, the company got bigger. We went from Fairphone 1 to Fairphone 2. Fairphone 2 was like the most repairable phone we ever had. Fairphone 2, I could just take out here and change the screen with one hand on stage, which was super cool, but not very viable for a market. So we had to go back to the drawing board and make something that was more sturdy. Went to Fairphone 3. I quit as a CEO because I wanted to sleep again, and some other people took over. And now I'm still in the board of Fairphone. But it's really nice to see the company growing and growing, also with people that really know what they're doing on the phone market, what they're doing on the impact level, and the skill that we are having is growing and growing every year. We're a profitable phone company. We have around 60, 70 million turnover. We're growing every year, and we're doing pretty good. And we've recently launched the Fairphone 6, and I'm really proud of that because it's a phone I haven't been involved in myself, apart from a distance. But I'd really like to show you the Fairphone 6 and compare it to that first video that I showed you, and see if some of the DNA of what's how it started is still in there. So that's the latest phone, but the great thing is, because we're officially a consumer electronics company now, we also started making in-ear headsets, over-ear headsets, and all with the same principles. So you can imagine I find it kind of cool that you can actually replace the batteries. You can take them all apart. You can replace batteries from your in-ear headsets. You can replace the batteries. You can replace all the components of the big headsets. But more importantly, again, it's not just the design, it's also what happens behind the scenes. And all these products share the same supply chain. And we can use that supply chain to also improve that whole assortment of products that we're launching. And just a little bit about the supply chain. We have impact areas because it's a super complex. People who are in hardware, they know, especially when you go into mass production, it's a super complex supply chain. And therefore, we divided it up into 4 areas. I was talking about the raw materials before, the mines where you get things from. I'm extremely proud that we were able to have a spin-off in Congo where we set up the Fair Cobalt Alliance. And a couple of, I think 2-3 years back, the big electronics companies got kicked in the butt quite seriously for child labor, because they found child labor in the supply chains in Congo. Yes, in Congo, anyone who makes electronics might find child labor in their supply chain. And what happened is that we set up this Fair Cobalt Alliance, and HP, Google, Tesla, they all joined our program now. So we're together with these big guys now setting up Fair Cobalt supply chains so that we can also improve the supply chains of batteries. We use 100% recycled plastics in the phone. I can go on and on. There's so many minerals in there, and we have programs on almost all of them. But we always do a mix of recycled resources versus mined resources, because mining in the end is bad, right? But we also don't want to neglect the fact that we do still need mining, and that we do need to invest into proper mining as well. These products are being made in factories, and we have programs in factories. We're the first electronics company that pays a living wage to the people, the first-tier factories that we work with. There's no one in the industry that does that yet, and we're trying to convince them to actually join us. You have to do that collaboratively, because otherwise your competitive advantage starts kicking in and these kind of things. We focus on repairing and recycling. Maybe it's nice for you guys if there's Citronics is a project that is a company that just recently started, which is built on parts of the Fairphone 2. It's like a computer company that sells computers based on our very old phones. It's really nice to see that this modular setup what we chose for the phone also pays off in terms of how people can reuse the actual components. On recycling, and just a bit on we're e-waste neutral, which means that we take back as many phones or sometimes more phones than that we put into the world. But the sad thing is recycling in this business is just a very stupid process. You collect everything, you put it in the oven, you burn it, and you get the minerals out. So, it's the last thing you want to do. And that's why most of our focus and where we have real control as well is on the design of that device. But it's not only on the design of that device. Like I told you, there's also the behavior in which you put that device into the market. Because I can make a device as repairable as possible, but if you still want to have that new phone every year, or if I push that phone into the hands every year, we have another problem. And that's, I think, one of the biggest challenges of companies. How do you behave in an industry where it's so competitive, but you also want to be more sustainable? And at Fairphone, we've chosen to work with dilemmas, because people are pretty good at dealing with dilemmas. And one of them is that we want to sell as many phones as possible, right? Because we want to show that there's market, and it's just one of our KPIs. But we also have a KPI that we want people to use their phone as long as possible. So you can imagine that's kind of a bomb in the head of a salesperson. Because a salesperson, a marketeer, wants to sell the next phone to people who already have a phone. That's the easy ones, because you have their address already, you know where they are. But we can't do that. We have to, we only want to sell phones to people that actually need a new phone. On top of that, we encourage people to use their phone longer. We have loyalty programs when people repair stuff or don't break stuff, that they get free repairs over the long run. And that is a cost-benefit thing that you have to, you always have to look at these things. Okay, how am I going to survive as a company doing this? And it's one of the areas where most companies don't want to go, and that's probably one of the reasons why all of them are focusing on recycling and not on having people use their product as longer. There's nobody that asks why do people even need 3 Teslas per family? No, you can also say if you want to reduce on mining, just 1 Tesla per family. It's great. Or 1 Tesla per 3 families. And that brings me to something that someone who said something about this is Gus Speth. You might know him. He's a researcher. He's been working on solving the big environmental problems for all his life. And he said, I always thought that the top environmental problems were biodiversity loss, global warming, and I thought we'd solve them with good science. And boy, was I wrong. The top environmental problems of our time are selfishness, greed, and apathy. And you can't solve that with technology. You can't solve that with legislation. You can't solve that with innovation. You can't solve that with what we're doing with our hands. You can also, you really have to look into, and that's what I believe, you need a cultural transition to get there. I think at the core of that cultural transition, there's different thinking about our economic systems, about how we make products, how we relate to products. At the core of that transition is re-establishing a healthy relationship with our products. Because something you deeply care for, you don't destroy. Because the most sustainable phone is the phone that you already own. Thank you very much.
Bas van Abel, ladies and gentlemen, thank you. Great keynote, thank you very much. Sorry, just switch the sides. And yeah, now it's time for a Q&A session.
Great.
With questions from the audience. But first of all, Fairphone 6 just launched, exciting times for the company.
Yeah, very.
Considering one of the last slides of your presentation, is it already in your pocket?
No, no, I still have a Fairphone 5, so I'm okay.
Cool. Let's go back in time for a moment, because I know that you, or I've heard that you co-organized a FAB6 meeting in Amsterdam in 2010. Does sitting here 15 years later in this theater bring any special memories for you?
Yeah, definitely. It's yeah, like I said, it's like going back to the roots, and I think I've you know what you if you run a business, one of the things I've learned with running a business compared to doing innovation is that when we were innovating at Waag, a lot of the stuff we were doing, you know, with 3D printing, at the moment that things were working and prototypes were doing it, it was like, okay, we've done most of the work, at least that's what I thought. Now the companies can take over and they can bring it to market, and that's not the interesting part, right? What I've learned with business is that if you want to bring something to market, 99% of the work you're doing is just dealing with legacy shit. It's just like dealing, if you want to change a system, and you choose to do that from within, you're going to be dictated by that same system you want to change. So you have to be dealing with all the finances, building a company, you know. So we had this kind of romantic image of you know, changing the world really fast. But you see, once you get into that world of an economic system, that you get also, you know, it kind of eats you at the same time. Yeah. So going back to, you know, my feelings about being here, I have really warm feelings about that thinking about that you can just, you know, that things can be made and can be done. Because if you are in that business environment for too long, you get cynical about innovations and new products and this and that. It's like, nah, it costs too much. No, we don't have to. No, we have that, and then it stops. And I think that was really the Fab Lab gave me kind of the strategic naivety, and especially Waag offered that kind of context to be able to be strategically naive.
I love it. I put it on my dictionary, so thank you for that. Are Fairphones open source, open hardware? If no, why? This is a question from the audience.
Sorry, can you repeat that one?
Are Fairphones open source, open hardware? If no, why?
Oh, if no, why? It's open source, yes. We work, you can download, open.fairphone.com, all the binaries you can download. But yeah, you can't build your own phones, guys. You can't, it's just, there's so much regulation involved, there's so much laws. And you can imagine it's kind of dangerous when people start making their own phones and like blocking the networks. You know, there's all kinds of certification you have to run through before you're able to get on the network. So what you can do is you can, you know, so that we have the binaries, we have all the open source parts. You can build your own environment, so you can build your own Android. So on a software level, high level, you can do a lot. On the low level, there's a lot of proprietary because we work with companies like Qualcomm. Unfortunately, they don't give away their source code. But on an operating system level, for sure. And we even have a collaboration with Marina. It's a French company. It's the former Mandrake Linux Mandrake group. And we sell in the US also. We sell Fairphone with Morena in it. And so it's a total Google-free phone. It runs on Android open source system, so yeah.
Cool. Will you produce laptops in the future?
I don't know. I don't know, it's not up to me.
Would you like to?
No,
Would you like Fairphone to?
No, I think there's a company doing that already, and I think I forgot the name, but Framework, yeah. So Framework is doing that, and Framework is actually a pretty cool company, and they've contacted me a while back as well. I wasn't, yeah, unfortunately I've been struggling a bit with my health lately, but I was, you know, they've been reaching out a lot on collaboration, and we've also been an inspiration to a lot of these companies, which is great. And I think, you know, it's always a bit of a balance. When do you compete with somebody, and when do you see that another company is doing what needs to be done, and they're good at it, and leave them do it? Because I don't believe in the winner takes all. I don't think it's also it's a bit of a more of a European mentality that you know, that we can all live together without having to outcompete each other, and I like that. I like that you also just don't want to kill other companies just because you want to have market.
Yeah. Xavier is asking, why didn't you choose to upgrade your Fairphone like a desktop PC instead of releasing a new Fairphone? I think you already answered that. Your answer right now, or
to use my old Fairphone as a desktop PC.
Choose to upgrade your Fairphone like a desktop PC instead of releasing a new Fairphone?
I don't think I fully get. You mean that it's been upgradable? Yeah, so it's upgradable.
Oh, yeah. Thank you.
Yeah, so I get that question a lot. I think it's a good question. The reality is that like 70-80% of the footprint of the phone is actually in the motherboard. So you can make it upgradable, but then you know you'd be. It's a very difficult, if you know what I mean. It's a very difficult. The peripheral is fine. You upgrade a camera, you upgrade this, you upgrade that. But if you start upgrading the main board purely, it means basically that you're already changing most of the phone. So we've been looking into doing that, and there are some research trajectories and partners that are working on it. But I haven't been convinced that is more sustainable, because people might actually also just get new motherboards more frequently.
Okay, how much of the hardware is made in Europe?
Not so much. No, it's. I think most of the production of technology is still in China. They're good at it, and it's also within. You know, people ask us, why don't you make a fully European phone? It's like, what's the use of that, right? It's the supply chain is in China. The supply chain is moving maybe now with all the the tension with Vietnam, with Taiwan to Vietnam to India. There's countries where highly skilled people are working on this, where also labor problems are still existing. But that's where we want to be, and that's where we want to make a change, and not just I can give you an example about mining. Some people ask us, why don't you go to Australia and mine there? There's no child labor there. But the problem is that most of the mining companies in Congo have left Congo because all these conflicts. People lose their jobs and start joining the rebels and become part of the conflict. If you really want to make a change, if you want to change child labor, if you want to improve situations, you stay there, you stick there, and you invest into the area where you are. You don't run away and just bypass the problem.
Yeah. Okay, what were the biggest trade-offs you faced balancing open design with commercial viability, and how did you handle them?
Yeah, so I think open design in Fairphone was an ambition to make a phone where people could also contribute. So the first phones, there was a question about the hardware as well. First phones, we released all the hardware, but we're a small company and so many challenges, and you've seen how much work we do. And being able to support even that was, you can't just throw some drawings out in the open and put some license on there and say, you guys, you deal with it. There's a lot of support that you need to give. So for us, it's been always a balance of finding the right partners that can do the open source part, which is the software part, which is most important. On an open design level, we have always very much also engaged the users into but that any company would do that, but also into the feedback loops of what can be different, how do we do. And one of the things that we've been doing in the past was that we launched the phone without cases, but with a voucher to print your case at one of the Fab Labs or 3D hubs. So that we were stimulating people to also get familiar with digital fabrication that way. So most of the accessories we launch also with the source files.
Okay. Oh, people want to challenge you.
Oh,
why did you not score an A on the Greenpeace sustainable scale you showed?
Well, I think there's always room for
improvement.
No, why not? I don't know. You have to ask Greenpeace first. But I know why. We're the fact that we were even green in that scale was the first time a company even was able to get there. And this was not even this test for Greenpeace. It was in 2016. This was like 3 years after we launched. I'm pretty sure we would score way, way, way higher now. And that Greenpeace was based on the chemicals used, on the carbon footprint, on everything you could measure, and nothing about the actual behavioral things that we were doing. None on the working conditions, on the mining, the supply chain transparency. So it was a very narrow kind of way also at looking at sustainability, and I think even Greenpeace has winded that. And if you look at all the ratings we have, just iFixit, people know iFixit here, probably a lot of them. We got a 10 out of 10, 5 years in a row, 5 times in a row on repairability. We score highest, all A's on sustainability ratings from operators. So I think we've also improved from that time. So I hope that answers the question.
Back in the day, what role did Fab Lab Amsterdam play in shaping your mindset as a founder beyond just tools and tech? Strategic naivety.
No, that's one. It's just it's the exploration. It's like one of the, like I said in my presentation, one of the most profound effects it had was that I saw how messed up the relationship is between us and the products we use, and how little we still know about how things are made. And I can tell you, when you go to a mine in Congo and you're standing there, and you're going deep into the mine, you have this stone in your hand that people just manually get out there, it does something with you. And for me, I think at BAG, one of the things that we always try to do is also to reconnect people, to kind of demystify technology, right? And this demystification of technology goes further than just opening up the black box and knowing how your Nintendo works. No, it goes all the way into the economic systems. I saw a presentation once from Dan Hill. He called it dark matter and Trojan horses, and he's talking about how if you design a product and you want to do it differently, as a strategic or as a system designer, you focus on the dark matter, because the dark matter is like 90% of the stuff that creates the matter. So most of your time you will be dealing with the economic systems, the cultures, the this and that, and not with the technology, not with the making. And I think at WAG and Fab Lab, it was for me an entry point through making to get into the more kind of philosophical, cultural, anthropological, and economical aspects of what drives technology.
Thank you for sharing. And the last question from Alex. Bas, do you sleep better today?
I do, yeah, I do. I do sleep better today. I have to say it was quite a stiff journey. I've had my collapses as well during that whole time, and I'm taking it easy now. So I'm happy to have a bit more distance from it, and that is wonderful. Just to see something that you've built grow in a way that is still so on par with what the vision we had at Waag at the time to have that DNA of Fab Lab and making still in the core of the company.
Thank you, Bas, for all your answers, for the wonderful keynote, and for being part of FAB25 Czechia.
My pleasure.
Thank you for being here. Thank you. Okay, guys, let's have a 20 minutes bio break. See you back on stage at 10:50. Please, we be here on time. Enjoy the break, and see you in a bit. Welcome back, Fab people. I hope you are well rested, because we've got more great session coming your way. But before that, let's take a moment to acknowledge another 4 partners of FAB25 event. Let's get to know them. First up, Chevron, global energy company that invests in innovative technologies and is involved in supporting STEM education and technology communities. Dassault System is a global leader in 3D design, and their Solidworks software is the standard for CAD design and a key tool for the maker community. The Fab City Foundation is a global initiative that connects cities using digital fabrication for local production and sustainable development. And last but not least, Škoda Auto equals with Czech engineering excellence. The company is deeply committed to supporting technical education among young people, and the company also has their own mobile Fab Lab, which you will see in Prague. Okay, now, break's over, but fun is not. Let's keep going. One of the core principles of the maker community is the commitment to openness and sharing. The open source mindset isn't just powerful, but as we heard earlier, it is inspiring and powerful. It has the potential to create real global change. But open source also comes with challenges, especially when it grows beyond a small project into communities and businesses. One of the most impactful examples of open source work in action is Precious Plastic, a project that connects thousands of makers and recyclers around the world. Its founder has spent years developing open source tools and systems to fight environmental changes and problems. Through Precious Plastic, he's helped to build a global recycling community. Through Project Camp, he explores sustainable living. And with Fixing Fashion, he tackles the crisis of textile waste. In today's keynote, he'll take us deeper into that journey and into one big question that many makers ask themselves. Is open source worth it? Let's find out. Please welcome Dave Hakkens.
Hey, hello. So yeah, I'm Dave, designer from the Netherlands, and I'm also going to talk a bit about phones. Maybe sounds familiar? Same as the previous guy. Anyway, yeah, I'm going to share a bit the lessons I learned from developing open source projects, because I've been doing this forever, as long as I have sort of my work life going on. And the lessons start a bit like 15 years ago when I was studying school. And so really basic, I just had an idea for a pen that could reduce the amount of waste, because basically the pen, you only really need the ink and the rest is there just to hold it. So I thought, what if the pen would be edible with edible ink, so then you don't have any waste. So I made this pen, was an idea. You could have it in different flavors. And then I put the thing online, because usually it was just in my school box at home, but I thought, let's put it online. And because of that, it spread around and people started talking about it. So I think this is when I learned sort of my first lesson here, which was like, it's quite powerful to share an idea, because suddenly other people can do something with it. So I figured, okay, cool. For the next project, let's integrate something else. Let's also have people help out, because just talking about something is one thing, but actually turning it into action, that would be cool. So I was looking into this other big problem in the world, as Bas just mentioned. It's like the fastest growing waste stream in the world was around phones. So back in 2012, I had my graduation project at school, and I had this idea for a modular phone, which was the principle, and it was really just an idea, like I made a video, but a phone that has the different components, and if something is broken, you can replace it, you can repair it, and they're all connected. And you can also customize it, so you can make the phone however you need, with the idea that you don't have to throw away your entire phone if one component is broken, but you can upgrade it. Back then, there was this website called Thunderclap. I'm not sure if it still exists, but the principle was people could sign up to support, and then all on one day, they send out the message like, hey, look at this project. So it would get a big attention into the world, with the idea that we just want to make people aware of this sort of problem. So yeah, within an hour, that website got overloaded. Within 24 hours, it had over 1 million views. From there, the project continued to spread all around the world in the news. This me talking Dutch television about it. Was even some people in UK that made some billboards. I don't know why, but cool. This guy from the Black Eyed Peas said it's the most dope thing he ever saw. So overall, it was pretty cool. A lot of people in the support reached, I don't know, lots of views, whatever. But the nice thing was that suddenly I got emails from companies. I mean, again, I was just a student on design school, so usually don't get emails from these guys. And one of the companies was Google, and they were working on something similar, but then they saw phone blocks and they realized, oh fuck, this is like a lot of people want something like this. So they wanted to accelerate the project, and this is me at Google, to see what would be the next step for the project. And so they wanted to try and build something like this, and they had a pretty hefty timeline because they wanted to build it in 2 years. But when I made the concept, I always thought like this would be a cool direction for electronics to go to, maybe in 20 years. But yeah, they were keen on doing it in 2 years, so I was like, sure. And when I first visited, they really had this massive prototype, but every time I came, it was like smaller, until in the end, they really had this super, like it looked like a phone. It was really impressive, like the thing could just boot and change swap modules as the phone was on. They called this thing Project ARA. Yeah. But then at some point, Google said, well, we're going to focus on software, so yeah, we're going to stop this project. So I was like, what? I just saw them build the whole thing, massive teams, massive amount of money put in it. And then, yeah, they just decided to not. And I think this is like, yeah, valuable lesson there, like, okay, then it's done, the idea finished. One of the cool things after that was that you do have companies like Fairphone that really have been putting the actual work in it, step by step, iteration by iteration, to make phones more modular. So really cool, putting in all that hard work. But I think the lesson here that I learned was don't rely on one company, because if they don't do it, the whole idea can be stopped. So I figured you need to sort of build a community around it, so the idea is not owned by one entity, but by like a large group of people. So then, for the next project, started again off with a problem, which was around plastic waste, seeing that less than 10% of all our plastic gets recycled. So most of it gets burned, goes to the landfill or the ocean, and all are just not really good. But then when I was looking into plastic, I realized, oh, this thing is actually recyclable. It always has this recycle logo, and if you chop it up and you heat it up, you can actually mold it into something new. So I wanted to figure out why doesn't this happen? So you have, so I just looked in the plastic industry, like how do they make this stuff? So I went to visit all these factories where they produce, where they package, where they design the machines that make these things, and where it ends up in the end, just to understand sort of the supply chain of this thing. And then I developed a few machines, kind of based on the industrial ones, but they cost hundreds of thousands euros. And I just made them in a way that you could build them yourself with more standardized parts from around the world, with the idea that then you can actually do something with plastic. Because up until that time, I don't know if you want to make something from wood, you get a hammer and a saw. If you want to make something from metal, you get a grinder and a welding machine. But if you want to make something from plastic, you don't have the tools. So yeah, the idea was making the tools accessible so people all around the world can actually do something with this material that they see laying around everywhere. So after developing machines also required a big material research. You have all these different types of plastic and different colors, and how do they blend together when you melt it? And does it come out the same way as if you thought it would? So in the end, I had this whole package of information from machine drawings, but also methodology on how to work with plastic, and I put it open source online for free so everyone could download it. Then people did, they built these machines in South Korea, Budapest, Indonesia, I think, Taiwan, Mexico, China, Spain, just a bunch of countries that make these things, Uganda, Ukraine, Bali, Czech, actually. And people use them to recycle plastic, but also for educational reasons, to really show people hey, this is what you can do with your plastic waste. And with this also the community started developing more products, what do you actually make with these machines? What's a logical thing? So in the beginning, the products were really shitty, but the project continues and evolves, so more and more products get made and developed, which is kind of the cool part, because for me, this was always the hardest part, like what do you actually make? So then you have all this people all around the world looking into that. And also each time we could get more like detailed. So the first time, I remember this was the first project that we did, like an injection mold from CNC aluminum, which was like a big thing. But nowadays, this is very normal in the community that they can go this precision. And at some point, we also were looking into, okay, this is all very small objects. How can we go bigger, like bigger volumes of plastic, and trying to explore these other areas of things that you could make. So overall, if you want to see more of this stuff, like hashtag Fresh Plastic, you find a lot on social media. But yeah, because all of that, we sort of set up this whole recycling network with these different roles. You have people collecting, you have people recycling, you also have machine shops and community points. So it really built this global community of people working on plastic recycling. And our role is a bit to like push always forward like this community. So at some point we had this idea, okay, it would be cool if we can have even bigger volume of plastic recycled and also make less of an end product, but more of this product that you can still do other things with. So we wanted to make a sheet press. So we took on the development, made a lot of prototypes, and in the end developed the sheet press that can make sheets. So you can really have a sheet from recycled plastic. I mean, it sounds very basic, but it just didn't exist and it wasn't open source available. So yeah, and then you have all this experiment, like how thick can you go and what kind of materials can you melt. And then people can also start using it to other machines like CNC cutters, which opens up this whole new possibility, or like bending it. So there's all this stuff that you kind of need to figure out because it's not like very straightforward. But once you figure it out and you document this, like, cool, everyone can do it. So yeah, this just made a whole new range of products available in the community. And what we also do is, so in the beginning it was all about, okay, we need to build machines, and then it goes, okay, what kind of products do we make? And at some point it was, well, we develop a lot of stuff, but ideally the community also takes on this work because you had all these solutions all around the world. And so it's to develop the software where people can document their solutions in order to make sure that, yeah, the information from all the people around the world can be integrated and people can learn from each other. And we also set up things like a marketplace. So if people want to, so not everybody wants to make their own machine. So in the marketplace, machine shops can sell the machine so other people can buy it. And I think this is actually a big difference from, so here's for instance a machine builder selling it. It's a big difference from other open source hardware projects because most of them sell something. Like, I don't know, Prusa sells a printer, Arduino sells the boards, but we don't sell anything. We're a non-profit organization, and we educate machine builders all around the world to build the machines so people can buy them locally. And also, if there's something wrong, you sort of have a local support. And also, it wouldn't put us at the center of the community, that we would be the ones providing the tools to everyone. So by now, there are machine shops all around the world, people that really build a business around making plastic recycling machines. So all of that had this was like something we tried to do yearly, is to get an impact report, trying to measure what a community like this does. It's really hard because we share everything what we do open source, so we only know people even exist if they say, hey, we used your machines, which rarely people, no, not rarely, but many people don't do this. And then the next step is we also ask them, can you actually upload your data? So a lot of information gets lost there. But anyway, yeah, so it's operating in a bunch of countries around the world. Last year recycled 1.4 million kilograms of plastic. And it also created a lot of revenue, all these machine builders and recyclers, a lot of employees and people and volunteers working on this project. So it's sort of like trying to get a glimpse of what a community like this does. But then recently, like last year, we sort of, after a few years, we noticed like fresh plastic is kind of a problem because it's cool that all those people, they have income and they build their business around it, but we as an organization not. So we had this long, I made this video with this long in-depth article that explains all the problems we had. As an organization, just trying to build this open source project, but then how do you make sure the actual organization can sustain itself? I guess it's a big problem many open source projects have. Yeah, unless you really sell something specifically. So the article has more information about it, but I think if I can summarize it in sort of one slide, is from our point of view, is that we spend a lot of time in the beginning like developing recycling solutions, and then we shared them open source online for free, so this made this whole network of community and people recycling plastic all around the world. And then we even provided business models because we really wanted to make sure that those people recycling plastic, they can sustain it because that's what we want, people recycling plastic on a daily basis. So we put a lot of effort into that. But then this next step, like make the organization financially sustainable, is just something we never did. So that's kind of the point where we are now. Like we did a big part of this cycle, but this last step, never integrated. So, I guess this is now where fresh plastic is at, like a half a year ago when I made that video, it was really at that edge of what do we do with this project? Is it gonna die? Because maybe it just did what it had to do. It's set up very decentralized and you have all these community machine builders around the world. It runs, it operates, people can share knowledge back. Or does it really need to continue and develop sort of the next steps of plastic recycling? So yeah, that's kind of the question where we were sitting with. Especially for you guys today, I have the announcement or the update that, well, actually the update is that on the 1st of September, we would reveal sort of the next steps for the project. Got one request here for you guys. Maybe you could make a picture with me of that slide in the background and put it on social media, #FreshPlastic, then I can use it to repost. So if anyone is up for that, would be really great. And as a spoiler alert, don't mention this, but yeah, so the question is, do we do something or not? But we're gonna develop a version 5, which is the next big thing for fresh plastic. It's gonna be a big crowdfund with it. We need 2 million euro for that, which is by far the biggest thing we ever developed. But yeah, that will go online that day. Hopefully we make it, we'll see. But at least, yeah, we're sort of trying to push the project forward because there's still way too much plastic waste in the world and way too much unrecycled plastic types. Yeah, so one lesson learned from this project was like, don't forget about yourself. You can give everything away for free to the community, but in the end, you probably play an important role to that because you sort of maintain the whole community. So it's really important that you find a way to integrate yourself. And yeah, so next time I would also say like set it up for like a long-term impact because these problems are really big and these communities grow really large. So you need to make sure you can sustain it long-term. So then I have, one more project. It's short. So, but yeah, the problem here started was like, how should we live as humans? Because I was working on all these projects, you also hear all these problems in the world, like, yeah, we can recycle stuff, but if we produce a lot of waste in the system we are, it's kind of inefficient. Then we leave a massive footprint of how we are organized as humans. Socially, many people seem like not necessarily super happy in the Western world. And also, yeah, just the quality of life of our routines, is it good? Like it feels a bit, maybe the culture was setting up. I don't know if it's ideal. Maybe it is, but I would like to try out another thing. So we started Project Camp, which was this idea of let's see if there's another way to organize ourselves, which has many questions, like the social aspect, but also how do you build your houses, what does a day look like? It's super complex. But yeah, we figured let's try to prototype a more sustainable way of living, and as always, share it open source so other people can learn from it. So what we did is we bought this piece of land, which the upside is, yeah, we don't have any rent to pay, so for the long term, it's kind of a safe thing. We set up some basic infrastructure, so we don't have any bills, it's all off grid, so it just runs there. Funny fact, this project, we also use a bit already to experiment, so this roof is made from recycled plastic sheets, or the toilet seat made from recycled plastic. So it's sort of a way to integrate these things that we're learning into a real-life setting, and try it out on a daily basis. Still runs after a few years. And we set up this team, so really a group of people that can continue the research and development. Because overall, this is like a multi-year, decades-long project. So we're really at the early stages of this whole thing. And we also set up like the income stream for the project, which we never did for Precious Plastic. In our case, it's this YouTube, kind of weird, but it works. We upload a video each week about the process we do, because on the one hand, it's very good for us to like document, because it forces us to document the processes and share. But it's also really what funded the whole project up until now, which, so that's kind of the model we have so far. We're currently in our 5th year. I think we set up a pretty good base. But yeah, like I said, it feels like this project is really just getting started, because it's going to take a long time for all the land to regenerate and the trees to grow and the houses to build. So the lesson here to learn, I don't really know. Probably there's something stupid we will do along the way, but I guess that's for the next update, maybe in FAB30 or something. I'll be here again. So then, I was thinking of this question, like, is it worth it, open source hardware? Also, yesterday, the questions around with Arduino, that in software, it makes a lot of sense, and in hardware, like, the giving back and stuff is not that well integrated. I guess it's more complex, and the tools are not really as optimized as software is. I think, to be honest, at this point, I'm not sure if it helped a lot yet. I mean, it helps to build a community, but you don't have this really powerful feedback loop as in open source, I think. But I still fundamentally really believe in that concept. So I think we'll just continue to work with it. We'll see where it leads us. And that's it. Thank you.
Dave Hakkens, ladies and gentlemen, thank you. Thank you. Good luck. Our next session goes by a title, From Maker Dreams to Market Reality. And we are going to explore what it really takes to take maker ideas into market-ready products. Our next speaker is an engineer with a passion for building things, turning ideas into reality, and a strong belief in open and transparent manufacturing. He's worked in almost everything, from scientific research to sustainable finance and startups, and eventually he co-founded Mechanica, an open-source hardware company based in the heart of Europe that builds not only CNC milling machines. His journey shows that open hardware isn't just an idea. It can be a real business model, one that stays true to maker values and still works in the real world. Here to share what he's learned along the way, please welcome Roldan Descamps.
Thank you. Hello. So I have 10 minutes to explain you the whole journey of Mechanica. For those who don't know us, we're an open hardware machine business based in Brussels, Belgium. And our story starts in 2015, so exactly 10 years ago. And as every good company story, it starts in a garage. I'm not in the picture yet at that moment, but my two co-founders, Martin and Maxime, who are somewhere here in the room, actually started a design and engineering service right off university. And they quickly realized that in order to not only sell ideas, but also tangible prototypes and products, they would need a workshop. And in 2015 in Brussels, it's the beginning of Fab Labs. It's not easy to have access to manufacturing machines. And so they decided to build their very first CNC milling machine. Sorry guys, I had to put those pictures up there. And actually, they learned a lot, of course, from their engineering and design background, but also a lot from online communities. They got in touch with the maker community, the open hardware community, and that enabled them to build this first machine. And from 2015 to 2018, a lot of things happened. But basically, I had access to a workshop next to a local Fab Lab called the Microfactory. They needed more space. We were friends from a long time, so we moved in together. And we started on our own project, but we started talking about this idea of making manufacturing more accessible and designing machines of which we would put the blueprints online so that anybody can make them, which is a pretty common theme in the maker community. We quickly realized after designing a few machines that, of course, designing and creating hardware costs some money. And we came up with the idea of creating kits of a very first simple machine, so a screen printing machine, a simple mechanical tool. And what we did was to just design a machine, put the blueprints online, and create kits with all the parts so that people would be able to just take the tool, build it, and screen print it at home. And this is, on the left, the very first inventory of our company. So we put all our savings together into those two IKEA shelves. And on the right, the very professional first photo shooting that we did. And that actually ended up on our first website, where we started an e-commerce shop. And even though it was very DIY, very low-key, we managed to have some traction. And after a few months, we actually started shipping regularly those first kits to get some money in and to be able to pay the rent and starting tinkering a bit more. And it's also a moment where in Brussels we started to have a little bit of traction on the fact that we wanted to design machine. And the school asked us if we could design a CNC milling machine for them. And as we already did it previously, it was for us a good opportunity to think, okay, maybe this could be our next kit, our next product that we would launch. And we were still having jobs on the side at that time, so it was a bit hard to have enough time to put into these new products. So we took the decision end of 2019 to quit our jobs and to incorporate our company that would become Mechanica. And this is a very crappy picture, but it's the only picture I have from that evening where we actually incorporated the company. And so we start 2020 full of hopes, with a lot of excitement of what we're going to do with our brand new company. The first thing, of course, is to design a second version of this CNC milling machine. We do everything in-house, actually. We're just 3, so we're like mounting the machine for the school because they don't want a kit at first. We're delivering everything on ourselves. We even go to a local maker fair to present it. I think we have 1 or 2 sales there. But quickly, everybody knows what happens in March 2020. COVID hits, it's locked down, nobody goes out anymore. For those who don't know it, it's the Grand Place of Brussels, which is usually extremely crowded. And the thing is, we're a brand new company, we're a brand that nobody knows. We are trying to sell machines online, and it's very tough, actually. It's almost impossible to get sales from that moment. But we have some time, and we have a lot of ideas, and by discussing with people, we realized that a lot of people would like to use the opportunity of lockdown to learn some new skills, like CNC milling. But that the first machine that we designed is a bit too expensive for them. So we take the time that we have to design a new machine that the objective is to create an entry-level machine, and we call it the Evo because the objective is to create a machine a bit in the idea of upgradable software, but a modular upgradable hardware, where you start with a very basic entry-level machine, and then you can upgrade it to a more professional one. So we create that first prototype, and to see if there's some traction, we decide to go for the big maker adventure that a lot of people are doing. It's to launch a Kickstarter campaign. So this is a bit like the 3rd chapter of the history. And we put the last money that we have into renting like a photo and video studio. We set up a pretty cool video, which is themed on a Zoom, where we're calling each other during lockdown in order to explain our project. And we set up like this Kickstarter campaign with a bit of traction, but full of hope that things are going to turn around well. Again, we're not very good in picture. This is the only picture I have of the evening where we launched actually the Kickstarter campaign. Very excited, but also very stressed, not knowing what's going to happen. And actually, it turned out pretty well for us. In the whole month of the campaign, we managed to sell 70 CNC milling machines, which was huge for us. We were just 3 in a small workshop. The only thing is that we quickly knew that it would be a problem to be able to ship and produce all those 70 milling machines. But as Massimo or as Bas was saying as well, when you don't know how hard it's going to be, you just go for it and you learn on the way. And so we went for it. We rented a bigger workshop next door, right where we were, and we started hiring a first team. This is the first team of Mechanica in 2021, and actually Nathan, our very first employee, is still with us today, and I think he's somewhere in the room here. And so this first team, our first goal was really to go for the production and be able to ship those 70 machines to the people we promised. And the thing is, I think you see already the next problem coming. Then once we manage to ship those machines, what are we going to do with a team that's only doing production? We need to find a way to get more orders and sell more machines, of course. So on the side of setting up this supply chain and trying to bring those machines to market, we're not really salespeople ourselves. We're more maker at heart. And so we try to find a way to sell machines, and we make a deal with a local distributor that is actually selling laser cutting machine that's willing to go into the CNC milling machine area. After a lot of work and a few sleepless nights working on this, we're able actually in October 2021 to ship the 70 machines to the people who backed us on Kickstarter, which is already a pretty good thing that we did because a lot of Kickstarter projects never managed to ship. And right after that, we have a very first order from the distributor, which is very exciting because they place a big order to get some inventory, and really have the feeling that we figured it out. Like, now we have a production team, they're going to sell the machine for us, it's going to work super well. The thing is, the distributor took a first inventory, and they quickly realized that selling CNC milling machines is way more complex than the laser cutting machine that they were used to. And what happened is that for the following month, they did not order anything from us. So we were stuck with the team doing production. We had a very binding contract with the distributor where we could not sell our own machines. The reason was that they didn't want us to compete with them directly. And so we were there with no further orders. And of course, what happens in a company when you don't have any orders? The cash goes down, and so all the money that we had from the first order and the Kickstarter slowly went down into the rent, into the salaries of the team, and we ended up in April 2022, after paying the salaries, with only 6,000 euro on the account. I really remember that day. It was a very stressful moment. But luckily for us on the site, since the beginning of the year, we started talking with people who were looking to finance impact project and open hardware project. And even though we were in a bad financial situation, we still managed to convince them that the product that we launched was a very good product. And they decided to still help us to sustain for a few more months. And we decided to break the distribution contract, even we were legally binded to them, and to go further into a bit mastering our own destiny, with the idea that if we wanted this company to work, we had to learn every step of the way and to do everything internally. And so at the same time, in 2022, we signed kind of fundraising where we get some money from investors that allow us to go a bit further into the company. The distributor directly assigns us to court, so we got a trial on our hands, which is a very hard moment for a very young company. We made it, and actually we won the trial afterwards, but after a few sleepless nights. And the lucky stuff is that we were so eager to make it that quickly after we made a lot of online tutorials, a lot of content, and we actually managed to get some traction, some people excited about Mechanica, about the machines that we were doing, and they started going up. It's also a moment where we were super active, where we developed other kind of machines. For example, this Fab CNC machine, which is a professional full sheet panel size machine that a lot of people were asking is the moment we launched it. And it's really, for me, the turning point in Mechanica, where we stopped being like this struggling project, and we moved into, while bringing more people on board to get all the sides of the business, into more of a collective story. From 2023, we were 10 people in the team, to today we're 17 people in the team at Mechanica, and we were able to bring almost everyone on board to come here to FAB25 to show them a bit what the maker community was. It's the moment that we moved into a new warehouse, so when you compare the very first inventory that we had and this new place, it's pretty amazing. It's also the moment we could start connecting again with the Fab Lab community, because when you work into your company, you really only focus on making it work. And this is the moment where Maxime and his team kind of won the FAB23 challenge in Bhutan. And end of 24 is really the moment we started seeing the bright future for Mechanica. It's the first year that we were self-funded and fully profitable. We've got more than 2,000 people using Mechanica machines on the ground everywhere across Europe. And I don't have the time to talk about our design methodology, about the community events that we're launching, about a lot of stuff that we're going to do next. So follow follow us online if you want to know more. But just know that all the blueprints of the machine we're doing are available online. Everything is open hardware. We started with CNC milling machines, but we're moving further into other machines. And we actually just developed a paper-making machine, a Hollander beater, that Maxime, my co-founder, is going to present later today at the university. Thank you for having me.
And yes, if you'd like to see some CNC milling machines from Mechanica in action, you can visit Fab Lab University track in the afternoons. It's inside the truck. And you can also go to Mechanica team, meet them probably in every other after party of FAB25, because we thought they are party animals, but after yesterday, we know for sure. So yeah, I challenge you to take a photo with Roldan so he has some content to use in his presentations in the future. But now, let's dive into the exciting and sometimes painful world of product development. Coming up with a great idea is one thing, but turning it into something real, useful, and ready for the market is something else entirely. And a lot can go wrong along the way. Our next speaker knows the process inside out and how to avoid the most common pitfalls. He's a true maker with a rare range of experience, from RC cars to hard valves, from IoT gadgets to mass-manufactured consumer products, and now supports makers and researchers at the Super Fab Lab at UNC Charlotte. And by the way, he's also been a NASCAR racing engineer, written over 200 articles for Investors Digest, and holds more than 10 patents. Today, he'll share the 11 deadly sins that can derail your product before it ever hits the market. Please welcome Jeremy Losaw.
There you go. Hello, everyone. Like I said, my name is Jeremy Losaw, and while I'm currently working at the Super Fab Lab in Charlotte, North Carolina, in the States, in a past life, I would help inventors and entrepreneurs, people who maybe didn't quite have the technical experience that we have in the room today, to help bring products to life. And through the course of that, we had wonderful successes and helped people bring products to market and start businesses. And then, unfortunately, there were some that never quite made it off the page. So that's what today is about, to help inspire you all to do better. So today, I'm going to show you some things, right? And what I don't want you to do is to feel bad or make fun of the inventors and the products that you're going to see. The only person you get to make fun of today is me, right? And so this is a product that I had many years ago now that failed. As you can tell by the picture, it was off the rails. And we'll come back to this later. But anyway, this is meant to be more of a cautionary tale and to inspire and to educate. So let's get right into it. So, innovating on a trend. This is a perfect way to not get a product to launch into market. If you see a trend, you should run the other way. So this was back many years ago. We had an inventor who had an innovation about fidget spinners. We started working on this project in September of 2017, and the peak popularity of fidget spinners was about 3 months before that. So despite the great design work that we did, this was never going to make it off the page. This is a common one, and I'm sure some of you that are trying to do this are feeling the pain of this. We just heard one a minute ago, right? So lack of funding can be a real big problem. It can take sometimes $75,000 to $250,000 to get a project from idea and into the marketplace with all the development and then the tooling and manufacturing. This is a wonderful product that was about mindfulness, and unfortunately we only had a few $1,000s to make some early prototypes. And while the product was really good and could have been successful, there just wasn't enough investment to get it off the ground. Losing passion, I think, is something many of us can relate to, whether it's with a product or just in life, right? So an inventor, yeah, this is, again, an interesting product. It was a husband-wife team. They wanted to create a keepsake box that would keep your products from degrading. So we launched a Kickstarter. Unfortunately, didn't do so well, and then the prototype was lost, and then they had an entrepreneurial spirit, and so they decided against hardware and decided to open a miniature donut shop and to focus on their real estate portfolio. So no points off, but just wrong place at the wrong time. Innovating for yourself, I think this is one we can all fall into too. So sometimes we just want to build the stuff that we like and the stuff that like serves a problem for us. So this product was a fancy spa shower, and this one, while it was interesting testing prototypes and taking showers with some of my coworkers to actually test this out. Turns out hotels have infinite hot water, if you didn't know. Anyway, so unfortunately this one didn't have the Kickstarter we hoped for. You know, the inventor, I think, was very focused on what he wanted to do, and so the product maybe was not the right fit for the clientele in the end. High cost of goods. So when I talk about cost of goods, I'm talking about the cost to manufacture and get a product from prototyping, from the factory to the consumer, right? So in this case, it was a sock sorting laundry basket. So we were manufacturing this product in the United States, the tooling, the actual steel to make the molds. This was like $300,000, right? This is big, massive stuff. And unfortunately, that meant we had to sell the product for over $40. And so this is, when a normal laundry basket is about $5, it was priced us out of the market. I'm going to pick on this one for a second, so don't tell him, okay? The products that we make need to have value. So when you design a product that has limited value, that's when you can run into trouble. So while some folks may have trouble sorting their socks and may need a solution like this to help, and certainly there are, the problem we're trying to solve is, if you can watch me, is this. Okay? Is that. So anyway, so this is maybe not a problem for most folks. And so the value for this product, you start to think about a premium product in a category that's a commodity type product, it can be an issue. Similarly, a niche market. So this product is a heated lacrosse stick. So for those of you who don't know what lacrosse is, it's a not very popular sport in the United States, but it's sort of like hockey, but in the air. Anyways, it's not played very much, and so this product was made for players who are primarily women players that lived in cold climates, so in the Northeast, and then for a sport that already wasn't very popular. So you start to think about, total addressable market, the people that will actually buy a product that you make. This is probably only maybe 1,000 people in the whole world may have a need for this product. So we did some awesome work. We took this thing to Las Vegas and showed it off at the electronics show. And just because we just couldn't possibly ever sell enough, we didn't get it off the ground. This one can be tricky. Sometimes you can launch your product into the wrong marketplace. So we built a hands-free spice grinder, which put a plate under and it would dose out your salt and pepper. Very cool device, very well designed. And so we took it to Kickstarter, and after a little bit of while, it just flatlined and we pulled it off. We know this is the wrong place to launch this product in retrospect, because we were actually very nervous. A month before we launched our product, a product with very similar functionality had also launched on Kickstarter, and they had pulled their campaign after only raising a few $1,000s as well. So despite this being an awesome idea, especially in the post-COVID world, this was just not the place to launch products. So you have to be cognizant about where your customers are and your best customers. IP issues. So this is intellectual property, so patents and trademarks. So this can be an issue. We talk about open source things and living outside patents, and I love that. But when you're trying to bring a product to market, you often do want some protection, or be aware of the other people in the other players in the market that have protection. In this case, so when pop sockets are very popular, you cannot charge your phone through a pop socket. So we spent a bunch of time, built a product to charge through a pop socket. It worked really well. We took it to Las Vegas to the electronics show. Great. Unfortunately, we walked by the pop socket booth, and they had recognized the very same problem. Okay, so their engineers had already gone through and built a wonderful product you can see on the bottom, and they brought it to Vegas at the same time. Unfortunately, this can not be a problem necessarily, but unfortunately, their patents were filed about a year before ours, so we had to cancel this one. When you launch products in the market, you often are subject to safety regulations. So like UL certifications and all that, right? So to make sure products are safe, these are good things. This product is a collapsible tea kettle. Again, very cool product, but you can imagine 100 degrees C water and something that can collapse. Not only can we burn ourselves, but maybe roast the electronics underneath it. So unfortunately, this one, even though it was a viable product commercially, was not a viable product regulatorily. And then when you get to product to manufacture, you're not done with the pitfalls, right? So you can have manufacturing issues once you get into production. In this case, very simple product, just an LEDs for dogs. And unfortunately, the factory used the wrong plastic. The clips that we made for it failed too easily. We had a lot of returns, and therefore, I had to cancel the project after just a single manufacturing run. So that was a bummer. So about me and making fun of me again. Okay. So I've done this professionally. I've seen the issues. I've seen people come in and have success. And these are problems that, the problem is these are so easy to violate, right? And so many years ago, I developed a radio-controlled car for racing purposes, right? There's a whole community of folks that do this. It's very fun, but I launched a Kickstarter campaign of this fancy new radio-controlled car to the tune of $230. Thank you very much. Super successful, right? So, thank you. Yeah, so I violated 5 of these rules, right? So I lost my passion for this thing. Primarily, my second daughter was born very close to the launch of the product, and I just felt like I just was out of energy to take this forward. This thing has limited value. It's a very niche market, right? I was innovating for myself. I thought it was cool, right? So it's just so easy to fall into these traps, and I'm not immune from this as well. So those 11 deadly sins, that's me violating more, like almost half of them, right? But what I want to end here, and to tie it back into our community, is that obviously many of us are going through Fab Academy, have been through Fab Academy, or just have things on our bench that we want to, that are in our heads and we want to take forward. And I'm in the same boat, right? I just finished Fab Academy and built this camera tool. And so this is a wonderful time, especially among friends in our community, to think back about, maybe the products that we have and being really honest with ourselves about if we really have a good product that has a willing market and, we're not violating too many of these rules. So appreciate the time, y'all. Cheers. Thanks.
Thank you, Jeremy.
Thanks.
Another great session from Jeremy Losaw. Up next is a story that shows exactly why supporting young talent matters. But before we get to that, let me just let you know that we are opening a 10-minute window of Q&As after the session, so make sure you send in your questions via Eventee app. To our speaker, at just 16, he founded Lassiter, a student team working on one of the biggest challenges in space tech, how to deal with orbital debris. Their idea? Use lasers to restore dead satellites and help clear space junk. A bold technical vision that impressed even NASA jury in the prestigious Conrad Challenge in the US. In 2024, that vision reached orbit, literally, with their satellite LaserSat launched aboard a SpaceX Falcon 9 rocket. Under Simon's leadership, this team grew from 5 to 35 students, building their prototype with the support of Fab Lab Brno. This is a perfect example of how Fab Lab can be the launchpad for young innovators. Let's hear the story from the one who led it. Please welcome on stage Simon Klinga.
Hey there, how are you? I'd like to tell you a story about how this little card, saying Fab Lab Brno, making you a 24/7 access to open laboratory with 3D printers, lasers, and just a lot of stuff to play with, can bring you sometimes even literally up to space. On 21st December 2024, this was happening here in Czech Republic.
Co si myslím osobně, je, že doopravdy dokážeme ukázat, že když studenti něco chtějí, a chtějí třeba i mířit až ke hvězdám, tak můžou. A někdy doslova.
Tak a přátelé, blíží se posledních pár sekund předtím, než odstartujeme. 10, pojďme společně odpočítávat. 8, 7, 6, 5, 4, 3, 2, 1.
But now, let's move from here, from Czech Republic, to the scene you can see up there. Welcome to the Vandenberg Space Force Base, a cute place located in California, where we are at approximately 4 hours a.m. waiting for our satellite, actually the first Czech student satellite, being launched up to space. And then this moment came to reality. But I'd like to talk with you not only about the project, about what we are doing, but maybe even more about the motivation that started this all. And here, I'd like to ask you 3 short questions. The first one is there anybody who ever wanted to be an astronaut? If you could just raise your hand. Cool. A lot of people. I love maker community. But second question, is there anybody who ever wanted to be a garbage man? Okay, we also have some people. Those of you who raised your hands twice, listen carefully to me, because maybe I have a dream job for you. Space bitch man, which might sound like a bit of bizarre, but to know why space debris is actually a problem today, we have to move up there. Welcome to the International Space Station, orbiting 400 kilometers above the Earth. Here, can you hear it? Can you hear the silence? And yes, most of the time, up there is actually a lot of silence. There is not many things you could meet. It's not like in some sci-fi way where you would be meeting, some spaceships just hanging around. But today, as we are launching more and more satellites every week, as SpaceX is launching about 60 satellites every week, the orbit is actually becoming a bit full of something we call space debris. Because if I show you this little cube that I will also eventually send to you, sometimes these satellites we are sending up there just stop communicating. And I'm just going to send it. And when that happens, you can guess what will eventually come as the outcome. The satellites will just spill like particles of Lego. And for you who have kids or something, you might know how much it hurts to step on a small Lego particle. Now imagine each of them is actually flying many thousand miles per hour, about 25 times higher speed than a bullet. And this is something we call space debris. A problem that can be dangerous for any other satellites, any space missions, astronauts, and all of that stuff. And also a problem which, with my team, we've decided to work on.
Historic success.
Great success of Czech high school students.
High school students dominate the finals of the prestigious competition.
Conrad Challenge at NASA Center.
They succeeded in the competition of 569 teams.
The competition had 3 categories and you won 2 of them.
Their idea was ingenious.
They had addressed an issue that's a big issue.
This undoubtedly great success, however, is not the end of anything.
Have you thought of using it as a weapon?
This was just the beginning.
A good question. Now, this is a project that actually, for those of you who, we've raised hands, we want to be astronauts. For me, being there, being in Space Center Houston, talking to people like Megan MacArthur, you can see up there, it was just very inspiring. And about her, actually, the most inspiring part was just how normal she actually was. You are talking to a person who was twice in space, and she's just, talking to like your mama, asking like, "Oh, what are you working on?" And it was very cool, and it was also cool to see her perspective. How I was explaining to her what we are working on, how we'd like to tackle space debris and all of that stuff, and how her brain works in the way she wanted to support, but wanted to support also with the criticism and the things that we could done better. And the thing I actually was talking about to her and what we've proposed in Space Center Houston was a method how to use high powerful lasers to actually tackle the particles of the space debris. Because if you imagine the satellites that stop communicating there and then eventually even spill like those particles, it is pretty hard to send there many, many satellites and catch them. So what if we would send there a high powerful laser to hit the particle or the non-communicating, non-functioning satellite with it, and eventually cause a burn or an ablation on the material. So there will be an action and reaction. It slows down a bit, not a lot, but a bit. So it goes a bit deeper to the atmosphere where the thickness of it is a bit higher. It starts to slow down more quickly, and then eventually it burns a lot earlier than it would normally. So that was the idea. But how could this be done by a bunch of high school students between 16 and 18? And I think the answer is already in my hand. Because I feel that the very beginning, not only of mine, but also of our team's journey, has definitely been connected to Fab Lab Brno. I'm from Brno, actually. I've been living here actually in this city. How much of you are actually from Czech Republic? Do we have even some Czech people, or most are from other countries? Very cool. So, and do we have anybody from Brno actually here? Cool, at least somebody. Cool, cool. So for me, for most of my life, I didn't even know a place like Fab Lab Brno existed here. Before I wasn't about 14 years old, about 3 years ago, I just once went there and we were just having a chat whether they could support us in the mission we are doing, in the project we are preparing. And they just said yes. And that is, for me, the moment I probably joined the maker community, because from then, with the Fab Lab Brno was a very good support for us. You know, having a place where you can be literally 24/7, and not only be there and have all the needed stuff and the place where you can work, but also to have the community and being part of it. You know, anytime you actually go to Fab Lab Brno, and I tell you to definitely visit, you meet somebody that is, I don't know, even at like 3 a.m. or 4 a.m. working on his project, being very passionate. And for me, as a 14-year-old kid, this was definitely a big source of inspiration and motivation. And for us, as for team, it was also a very good place where we could cooperate together, and not only on work stuff, but sometimes also, you know, watching movies. And don't get distracted by this red light. We were watching Oppenheimer, I think, or something. So for me, Fab Lab was a very, very strong community to begin with. And then it eventually got even broader, because Fab Lab is actually in Czech Republic. The Fab Lab Brno is like part of the South Moravian Innovation Center area, where they have many supports for startups and all of that stuff. It's not just one community, it's a whole ecosystem, how you can get from 14-year-old kid to 17-year-old kid to sending a satellite up to space. And part of it definitely wasn't just, you know, us as a students, but as you can see here, I don't want to be like bad at those people, but you can see that not all of them are high school students. So these were the people who also helped us. There are the people, for example, from Czech laser centers in Dolní Břežany, with whom we've been actually, and we are right now cooperating on developing the laser system to tackle the space debris. And yeah, again, not only in the lab. And because of this support with my team, we've been actually able to do the thing that we could actually develop our own satellite. Ladies and gentlemen, this is LaserSat. So we've been able to actually propose our own satellite in a very short time, because in the competition in Space Center Houston, that actually helped us a lot in the motivation and validation of our project, because, you know, just some guys from NASA said, yes, it's good, maybe you should carry on, which was good. We've actually started partnership with also one Brno company called SpaceManic, who is working on satellites. So together, we've been actually in less than half year from winning the competition in Space Center Houston to develop the satellite and then send it from Berlin with ExoLaunch to the United States to be later launched on Falcon 9 just last year. And on that, right now we are testing the method, how we could, like how much energy we'll get there, because the satellite, you know, it is the one I sent you. It is just a small CubeSat, so we couldn't fit a gigantic laser onto that. So basically for us, it is a perfect target on which we are aiming from the Earth, from Dolní Břežany with lasers to get the information how much energy got there. We have there a small testing material of nylon to cause the ablation on it, to try how much it could, just a little, but how much it could change the direction and traction of the satellite. But this is, for me, again, just one part of it. Because right now I have a few photos from one other FAB community event. Because for me, there is the different part of, again, pushing another students and even kids to getting to not only the maker community, but the community of passionate people about science. This is Lucy, and when I asked you, who of you ever wanted to go to space, Lucy really wants to go to space. And for kids like Lucy, with our satellite, we are right now preparing projects like antennas to schools, which sounds a bit weird, but we are just sending to schools for free antenna kits, you know, just a basic Yagi antennas with which they can aim to the satellite that is flying over their head, and they can get the information that the satellite is actually sending here on Earth, decode it, and that stuff. For kids, with cooperation with Prague Planetarium, we are also working on some lectures for small kids to learn how they could program just a short, easy code that we send to our satellite. And based on the code that the kids create themselves, our satellite takes a picture of the Earth that is then theirs. So that's also some other stuff we are working on to make the maker community and also the idea of science and space accessible to everyone. Because in Czech Republic, I think we are pretty much tending to not be sure whether we could be part of space, and you know, we have all of these discussions whether we should pay for sending our own astronaut to space and all of that stuff. But I feel that there is a lot of people, and especially in the maker community, that can make projects like ours happen. And you know, today, Czech Republic is really a place where a bunch of high school students can send their own satellite to space. So here, I'd, in the last 10 seconds, just like to thank the maker community for making such a good space for sending things up to space. Thank you.
Thank you. Wow. Simon Klinga, leader and founder of Lazar Crew. Simon, would you like to sit with me to address some questions from the audience?
I'm just going to carry the Lego because once I didn't do it, and everybody was like, you are talking about getting rid of space debris and you can't just, yeah.
Okay. Hi.
Hey
it's
there.
very nice to see you right
Yes.
here on a big stage. We hosted a podcast of Fab Lab Brno together, so...
But then it was a bit of fail because of my calendar, so sorry for that.
But you have more important stuff to address now, so we are happy to have you here.
I'm happy to be here.
Let's take a look at some of the questions. Your team grew from 5 to 35 people. How did you manage that growth, and what have you learned about leading a team?
I think I'm in a very specific position because, you know, we are still not a company. So we are not paying the people that are involved in the project. So I feel I really have to work directly with the motivation of people because there is nothing else. Like, I'm not giving them anything beside the motivation. So, or their motivation that they want to send something to space or something. So I've definitely learned that it is good to not force anybody to do anything I think would be the best, but just to work with the people in the way you just find what drives them the most, and then you like help them to get there. So that's why we are, not just working on the satellite and space debris and everything, but also working on the science education things and all of that stuff. So I think I think it's a lot different to have a group of 5 people than a group of 40 people. Because right now it's, we've actually had like a working session in Fab Lab just like a week ago. And I didn't even know it was happening. And I was like, oh, like we are just 40 people. And there are things I don't even have to know about because, we are doing so much. And there are like groups of 5 people actually working together because I found it actually mostly effective to not have like a gigantic group working on something, but to break it down to smaller parts.
So the art of delegation, right?
Yeah, also. Yeah.
Not so good at it.
No, just getting there. I think as many other people, have problem with saying yes to so many things, and then I can't do everything, but getting better on that.
You're getting there, yeah.
Yeah.
Why you did not work with European Space Agency, ESA?
We actually have some talks with them, especially with the European Space Agency's Business Incubation Center that is here in Brno and in Prague. We are also talking a lot to the European Space Agency's resource office, which is just their education agency. So with their education agency, we are cooperating on the antennas to schools and all on the lectures with Prague Planetarium, also with ESERO. And maybe in the future, right now we are more in the phase of still being a student project, not like, being that much driven to market, because for us it will be a long-term run to really develop a lot of stuff. I think we'll have stronger cooperation with ISABIC in the upcoming years.
Okay, insightful question from Adam. What wavelength of light did the laser shoot from the Earth?
Yeah, we are actually testing 2 wavelengths. One is infrared laser, so about 1,000 nanometers, and then we are also testing green laser. Each of them is better for different stuff. The green one is just cheaper, so we've started with this, but the infrared is better because it goes a lot smoother through the atmosphere. The green one does a lot less. So, but it has also like different perspectives on it, because with the green laser you can have some impact on silicon chips, so we can measure better way how much of the energy got actually through the atmosphere. But with the infrared it is harder to have chips that can measure it so precisely. But for eventually the ablation and slowing down the particles, the infrared is just the best option right now.
Okay. Alex wrote, I feel sad for the guy in the video still waiting for the answer. Have you thought of using it as a weapon?
This is the thing we call dual use. And sometimes it is good when you want money to have dual use. But I mean, in the industry of using lasers as weapons, there is a lot of money. You may know projects like Dragonfire from Great Britain, and the US have a lot of that stuff also. So I feel we wouldn't probably come with something new in that perspective, or in that field, because there is a lot of pressure on using lasers that way. I think we can find new stuff and develop new things in the way we are using lasers in, again, different area, because I feel that today space debris is not yet as big problem that companies like SpaceX would really care about it. Yeah. But I feel maybe in like 10 years it will be a lot bigger. And because in Czech Republic we have very good laser centers, all of that stuff, I feel we could be actually on top of that trying to tackle space debris. But I feel we really need to start right now to get there, because we won't have as much budget as United States or anybody.
Yeah, sure. What were your references to build the satellite? Guides, previous developments?
For us, it was mostly about a cooperation with Spacemanic and with the Czech Aerospace Research Center. So primarily, actually, we weren't that much running on the resources from the internet and the web. Like we were primarily cooperating with the companies and trying to like find a way what systems we could get there, what chips and all of that stuff, so we could measure all the data we need. So yeah, for us, it was probably, this is the reason why we could have get there in half year, you know, from just an idea to sending a satellite, because we've got good cooperations, and with the people, it was a lot smoother and faster.
Cool. Anastasia is asking, did you patent it?
Not yet, we are in the process.
Okay. What are your plans for after high school? This is a good one.
Yeah, it is.
Because you have your 18th birthday in September?
Yeah, I do, on 2nd.
September 2nd. So you are becoming officially adult in Czech Republic, even though you are having pretty adulty life right now.
Yeah. Yeah, and a fun fact why Sonia knows when is my birthday is actually because she was on my birthday party and didn't even know about it.
Didn't know about it.
And because just last year, on 2nd September, we were announcing that we are planning to send our satellite up to space on one conference here in Brno. And it was funny because it was my birthday, and on my birthday I could like say I'm sending a satellite to space, and there was like a prime minister and ministers and all of that guys, and they didn't even know they came to my birthday party, and it was very good.
Very original birthday party.
Yeah. This birthday I will probably be already in the United States, because next school year I'll be actually in the States. So what I'm planning to do after high school, I definitely plan to carry on with projects like Lassiter. I think I really enjoy, you know, when I was smaller or younger, I was thinking about whether I'm like more of the scientific guy, or I also like this scientific popularization, like where is my place? And today I really feel my sweet spot is in like founding the projects and being in the phase when you are creating it, and you know, you are picking the people you want.
You are the activator of the things.
I like it. And I feel that it's a lot of fun, because, you know, for sometimes you can work on the satellite and the tag, then you can work with the people, then you can knock on the doors of some ministers and asking like, do you have 2 million crowns or 2 million for the satellite? And it's so diverse, and I enjoy this so much.
Thank you, Simon. That's all we have time for, but thank you for your answers and
sure.
for your speech.
Thank you.
Simon Klinga, ladies and gentlemen. Okay, next up is a story that shows what can happen when industry, education, and the maker mindsets come together. Our next speaker is an engineer at Toyota, where he's worked on future mobility systems, including projects like the FAB25 concept and the kinetic seat, rethinking how we move, ride, and experience mobility. But today's talk isn't just about the design. It's about what happened when one of his industry projects crossed paths with Fab Academy program. Through open learning, hands-on making, and real collaboration, he prototyped a Fab Lab vehicle seat, bringing real innovation back to one of the world's biggest car makers. Let's hear more from Koichi Kato. Welcome.
I am an engineer, and I have been the contact person for MIT CBA consortium membership in Toyota. To make my story short, Neil insisted I join FAB25 Mexico last year. There, I met Anastasia. Then it changed my life. Yeah, thank you. I joined the Fab Academy program, and this is my output after 6 months, called Favorable Kinetic Seat. Here's my final project video. How you transport for the moment
motorbikes. And then we use our head.
What about three-wheel motorcycle, like a tuk-tuk? They don't have tuk-tuk, and they cannot afford. It is made in Kenya. Buying the tuk-tuk it is affordable, and then we'll be having a lot of them around here.
One of the reasons why I created Fab Lab is because of the high level of unemployment in the community. We don't have major manufacturing industries. A lot of young people do not have what about computers? Where young people can come, learn, we created Fab Lab, which is having a vision of community empowerment through innovation and local manufacturing, so that young people can have local manufacturing companies. Is there a recommendation that you can tell him?
The roads are not very good. So let's start from the chair. The chair should be designed to be comfortable in relation to the types of roads.
Relaxed, my hand is helping. Actually, with me, I even used my phone comfortably. I could see everything, and your head remains steady, and your body just moves with the chair, and it feels so good. We've tested it on a bike, and it has worked so nice. So let's try it in a tuk-tuk and see how that works.
Okay.
On this seat, you feel very comfortable. You feel the bump.
The two lateral motions. Okay. Yeah. The lower seat, what the recess we made, made a big difference.
Yeah, honestly, I feel relief. I think it might work, but it worked very well. The motion range is much bigger than the normal seat that we are developing. I could confirm that it could also work with the belt. Thank you very much for your hard work. And it worked very well. I'm so happy.
Wow, thank you. Thank you. I visited Kenya for 3 weeks and learned the farmers have difficulties of transporting their crops because of 2 points. First, the terrible road condition. The second, there is no manufacturing industry in Kenya. So they must buy expensive, high-tax imported vehicles. For example, an 8-year-old Japanese used car cost 1 million Kenyan shilling will cost Kenyans more than 2 million Kenyan shilling. Considering the average daily income of Kenyan smallholders, farmers, as of 400 Kenyan shilling, the situation is very severe. Although it is difficult to dramatically decrease the price of used car, I thought about dramatically decreasing their first pain with our technology. To make their vehicle comfortable, I want to introduce them my kinetic seat that I have been developing in Toyota. Human spine had been developed to stabilize our head for hunting animals. The kinetic seat is designed to utilize the spine function to stabilize our body and head with its motion. The spine lean, it has two rotational axes, one in pelvis, one on the chest. The spine leans inside of the corner along these axes due to the centrifugal force. The seat provides the reaction force to support our back during the cornering, and the spine function stabilizes our head, especially on the bumpy road. I want to make this innovative seat accessible to farmers in Kenya as a made in Kenya product. The kinetic function utilizes the seat fabric to hold the driver's body firmly in place. Therefore, the seat could have more function with the use of novel and sustainable materials as fabric and fabricable. Then what about the frame? The standard seat frame is made of steel and requires complex sheet metal processing. Could a seat frame be fabricable? Well, my instructor Kae suggested me of designing seat frame by wood. Rico also liked this idea. Then I started to consider designing the seat frame by wood as fabricable seat. This kind of out-of-the-box stimulating idea is one of the most high point while I was having the fabricating program. With the instruction from Anastasia, I designed a wooden frame which can be easily manufactured. Joint design for CNC. Wood board selection failed with the block wood first, then failed again with solid wood. Finally, we succeeded with the plywood. Considering the recycling and strength, discarded car seat belts were chosen as a seat fabric. Found the way to cut the seat belt. The belt and adjustable finishings was done by Fab Lab Venom. One part designed to be 3D printed. Strength analysis has been done. In summary, the fabricable kinetic seat was designed in Japan, sent as a data, fabricated in Kenya. 2 patents were filed. Next steps are installing into tuk-tuk and small truck. Then we will further investigate to use the local natural materials, such as bamboo, fish skin, papyrus, and water hyacinth. Then we will start proof of concept, testing by local farmers in Kenya, then develop a profitable business model with Fab Lab Venom. We made future innovative function with accessible materials and fabricable. At last, I want to show you the performance of this seat in actual sport car in the passenger seat. Please compare the head motion in the kinetic seat in the bottom, head angle leaning inside of the corner. Compare the head stability on the bumpy road. Look at the chin at acceleration. At braking, the head dive doesn't occur on the favorable kinetic seat. Thank you.
Koshikato, ladies and gentlemen, thank you. What a great example of what is possible when a global company, individual maker, and digital fabrication program join forces. But now to wrap up today, we'll hear what happens when Fab Lab is more than just a workshop, when it becomes an engine for real-world innovation. Our speaker leads a tech education program at Unternehmertum that is according to Financial Times, Europe's largest entrepreneurship center. He works at the intersection of making education startups, helping new founders turn ideas into working prototypes with real-world impact. His stories show how Fab Labs, when plugged into a strong ecosystem, can support maker-to-market journeys with global potential. Please welcome Michael Lorenchk.
Hello, hi. So I want to conclude this session actually with some positive aspects of how do startups really get successful if they're focusing on hardware. So maybe an additional perspective to the 11 deadly sins maybe. So in this triangle of talents and startups and corporates, they can all learn from each other and they can all collaborate at somehow if you think it as a network. So that's what we do. At Unternehmertum, we always ask the question of what kind of world do we want to live in today, tomorrow, or in 10 years. So there's always technology involved, but how do we deal with this tech? So in terms of circularity, for example, robotic solutions, mobility solutions, but the education of that is always a bottleneck and at the same time a central resource of Europe or of the whole world. So that's where we come in. So these are some, I was looking at the wrong screen. So yeah, that's what I was talking about. So these are the startups that have reached the unicorn state. So everybody knows Flixbus, but for example, Celonis is kind of a hidden champion. They do process mining, process improvements. And in ESA Aerospace, they have built their rocket parts in our workspace, for example, and have not completely successfully, but launched their rocket in Norway in March, for example. But in the end, it always boils down to the human level, to multiplicator personalities, to really inspire other people, hundreds or thousands of students and of young people, giving lectures in their respective areas, taking their startups forward. So all of these people are young, but they really shine in the ecosystem. We have 17,000 participants per year, roughly, in these programs. So all kinds of different programs, not only hackathons, for example, but coaching formats of 3 months, for example. And we work with over 1,000 startup teams, and 120 of them were scalable last year, so they received funding. So in this ecosystem, the Unternehmertum is a non-profit organization which is only closely but not completely linked to the technical university. So we have some kind of freedom, some kind of operative flexibility. But there is a joint venture structure that also gives out these special resources to startups when they need it. For example, agricultural spaces which we don't own, or chemical labs, or these airflow channels for aerotech space applications. So if you look at this network, we have published a white paper about how can these networks arise in Europe or in bigger areas locally. If you combine all these collaborators in a manner of really working together, involving in decision-making, for example, also the government, to not involve it too early, but also not too late, just at the right time. That's what we focus on. And the magic really happens when all these people meet each other face to face. If they, for example, attend a conference, we did this thing that we did a hackathon about circularity, and these students were building little prototypes about, for example, textile sorting, computer vision based, for example, or microscopy based, and they were showcasing them on a final event. which was at the same time the kickoff event for a scientific conference. So these politicians and these scientists could meet these startup or students, people, and they're really discussing beautifully. So this is what Unternehmertum has been doing for 23 years, and since 10 years, so not a long time compared to this, since 10 years the Makerspace high-tech prototyping workshop exists, and we have 2 locations in Munich, focusing on these classic areas, also early-stage prototyping, laser cutting, 3D printing, but also metal production, CNC milling, so actually the whole range. With a total area of 3,000 square meters, for example, we have a water jet cutter where you can also freeform cut carbon fiber, for example, plus the special resources from the university that startups can get. But what I want to present to you is I've done some interviews with people, not only from startups, but also from the platform, about what is the common denominator that successful hardware startups do. So first of all, for example, they take part in these industry-relevant hackathons, solving real-world challenges and finding a team, finding like-minded people to really stay on the challenge. And then really focusing on a core set of functionalities, not losing themselves in details. So really pushing an MVP out there, minimal viable product. And then also focusing on patents early. That's what also Jeremy told. If you have this collision of someone else filed a patent 1 year ago, you're basically screwed. So thinking about it early, that's what people did. And also just looking at current research, what technologies arise, what technologies can you also use in your product. This really helps. And asking technical experts of the network. So also always have your story ready to tell. Always, no matter who you meet, which persons you face, you can tell a story about why it is relevant. How can you, make yourself known to different kinds of people. And then the ladder of FDM printing a lot, then a little bit of wood prototyping also before going into metal, as the engineering rule of 10 to really save up costs and hassle in the end. So FDM printing actually for all teams was one big starting point, no matter what they prototyped in hardware. And if it comes to serial production, that there's no, let's say, little bugs that kill you in the end in serial production, it's really important that we give them the personal operation of these production machines, for example, also PCB pick-and-place machines that can operate on themselves so that they can find the important point of the serial production. And also what they did a lot of times was early desirability testing, so to go out to potential customers to say, do you want to buy this product? Would you, at what pricing, for example, and also usability testing to observe potential users, interact with the prototype even, to learn and to co-create at that early stage, to really find out how users think. But at the core of it all, there's this young nurturing, like we did with Simon, like we saw with Simon, for example, just now. If they start early, if they are used to setting up technical projects, both of it, they can really go places. So that's why, since 2 years, we built this STEM youth program as an empowerment culture. We really focus on all kinds of schools to not leave anybody behind. So actually to go to these schools who have always been told you won't make it on the job market, you can't do tech, that's nothing for you. I go to them and say, let's prove them wrong. Let's do a hackathon, let's build something cool, and you discover your skills and your strength, and then you have a full new perspective afterwards. Also what I did is, for example, I did prototyping sessions with handicapped people because they are natural-born problem solvers. They do it all the time, so that was just great. So what we also do at Makerspace is to give out free access to any kind of students, no matter what they study. They can build prototypes in our workspace. Of course, they have to do the access courses for the machines to work safely, operate them safely. But from that, they go also places. And the hackathons, there are 3 different types of hackathons. The open ones, where you can just bring any problem and find people to solve it, or definite challenges posed by companies, or even direct matching of engineers and students who work together for 4 or 5 days on a really concrete problem. So one example that I want to illustrate is angsa. It's the Malaysian word for swan, because of this white sucking head. So this sucks up little trash that's laying around. So these were four students sitting in a park, really annoyed by these little cigarette butts and the beer can lids in the grass. And they wrote an email to the government, and it came back, no, we don't have money to clean this, of course. So they said, let's build a robot who does the job. And they did in a hackathon. So this upper photo was actually 4 or 5 days of building intensively, and it worked. It was the MVP, which they based on, and then they founded a company, they got investment from Husqvarna, and now they are in serial production. So in 1 or 2 years of time, you might see one of these driving around in a park. And another example I want to illustrate is the ready, fire, aim principle, which is well known to this room, of course. So first, get yourself into position, do your homework, then put something out there, and then as a third step, important step, get some transdisciplinary feedback and find other, even more interesting solutions and applications. So All Underground was a startup who was a spin-off of the Hyperloop Challenge, so the student challenge that Mr. Musk announced. And they won that 5 times because they were intensively building and improving every year the prototype of the high-speed train. And then, as a succeeding challenge, they had this tunnel boring challenge, and they even won that 3 times. And then they stood there with a high-tech, really high-performance, tiny tunnel boring machine. So they thought about, what can we do? Upscaling would be way too easy. We would lose our engineering ingenuity in this tiny 40-centimeter diameter tunnel boring machine. So they identified cable laying of electricity cables as a perfect fit. So now they're accidentally really innovating the market of the energy infrastructure. So what I always want to say in the end is it's a responsibility of bigger makerspaces, of whole ecosystems that arise locally to really focus on all kinds of talent groups, to not leave anybody behind, because these interdisciplinary teams, they are really resilient and they are on a mission. Yeah, so that's what I always want to do, unlock hidden potentials. Thank you.
Michael Lawrence, everyone.
Thanks.
Thank you for your presentation. And guys, we've reached the end of our Maker to Market ride, and what a journey it has been. We've seen what's possible when ideas leave the workbench and head into a real world. But now, to the day wrap-up. Now it's time for your lunch. Remember, afternoon workshop starts at 2 p.m. The lunch pickup went quite smoothly yesterday, but to make it even more efficient, please only pick up at the vegetarian stand while you are having the green dot on your badge. So it means you have selected the vegetarian option while buying a ticket. It's possible there might be some portions extra, but we cannot guarantee it, and you have to wait until all the people with green dot picked it first. The evening, you have a chance to explore the city all by yourself. Don't forget to check the official map with recommendation. You can find it in the Eventi app and also on our website. And from 7 p.m., you can come to Harry's. It's a local brewery we booked for you. It's just a few minute walk from here in a vibrant city center, and it's a nice place to enjoy the best beer in the world. Okay, see you tomorrow at 9 a.m. Enjoy the rest of the day. Bye.